No. I think that's about it. So handouts are in the back. If you guys want to go out and go back and grab one, that would be excellent. Or maybe someone can just come down and pass them down, or something. You guys can organize. You're hopefully programmers. So let's start by just talking about what Django is, right? If I can get these slides to work. So Django is essentially what we would commonly refer to as an MVT framework. You've probably heard the MVC concept before, Model View Controller. Well, that's not really what Django is. Django subscribes to a slightly different concept, or sort of a version of that concept that's referred to as Model View Template. The model is essentially a data model, right? So it's the way that we store data, it's the way that we retrieve data, it's the way that we query information from a database. And in fact, there's a whole modeling language that allows us to define databases, to query databases, to do advanced queries with aggregates and joins and so on and so forth. I don't have a it's going to be online, but I don't have it right now. So, so the question was, is there a soft copy? It's going to be online eventually. I don't know. I don't think they post that stuff until after the talk finishes. Otherwise, you guys wouldn't come because you'd have everything already. Half of you have probably already walked out after grabbing the slides. No, just kidding. So the idea is that this modeling mechanism allows us to model the entire data model, right? All of the information that's stored in our database is done using a Pythonic syntax. It's all done right within the Django framework. Now, the cool thing is that if you develop and you design and you use this model, it supports a wide range of different databases. So today, you design your very small database using SQLite. It's really only, it's kind of like your mini Facebook, and it's really for just you and your close friends, both of them. But then, all of a sudden, it grows, and you go, oh, wow, I need a real database. I need PostgreSQL. Well, if you use Django, it's easy to migrate. Because if you use the modeling language supports a wide range of different databases. It supports SQLite, it supports MySQL, it supports Oracle, it supports PostgreSQL. And if you really like another database like DB2, you can write the extension to support it as well, contribute back to the project. So we've got this model language. The concept of a view is essentially all of our program logic. The idea is when a request comes into Django, Django hands that request via the web off to the view, and the view does all the work, right? It makes sure that you're authenticated. It does the queries against the database. And it takes something that we refer to as a template, and it populates it with data. So a template, if you guys have ever worked with templates before in something like OpenOffice, a template is more or less the same thing. You've got a whole bunch of variable substitution components and even some program logic, very basic program logic, something that hopefully your web designer who doesn't know Python is going to understand. And you can use that program logic to populate the template with a wide range of different data. So the idea is that we've got the model for the data, we've got these views that handle all the program logic, and then we've got this concept of templates. Now, one of the cool things about Django is it has very elegant URL support. The idea is whenever a request comes into Django, what Django does is it uses a series of regular expressions to match the URL with one of the views. So Django uses a regular expression to match a URL to a backend view, and then it calls the view. When it matches the view, or it matches the URL, it can even pull things out of the URL, like parts of the URL, and pass those as arguments into the view. So these views can be very dynamic, and of course the views have access to all kinds of cool stuff. They have access to information like get and post information. They can set and get cookies, and so on and so forth. So the views really have everything that they need to build this output using these models. Now, Django can do a lot more than just your basic, simple website. Obviously, it does. But it also has support for cool things like geospatial technologies. So we can, for example, use SpatialLite, or we can use PostGIS, or MySQL Spatial, if you're a glutton for punishment, notice I didn't say MySQL, if you're a glutton for punishment, just MySQL Spatial. To do lots of cool location-based things with Django as well. So very, very cool tool set that we're going to learn about today. Installing and configuring Django. Now, hopefully you guys all went out to the web and you saw these basic instructions before. I'm not even going to go through the installation of Django here because hopefully you followed those instructions and you're already there. But really, it's one command, sudo easy install Django. All right? Everyone get that? Sudo easy install Django. The idea is the normal easy install mechanism is available with Django. Today, for this tutorial, we're going to do things using this Spatialite database. The reason I chose to use the Spatialite database is I didn't want to bore you guys with all the complex details of installing a Postgres or a MySQL database. Spatialite is a flat file database, so it's essentially, well, it's not just flat, but it's a file that's on disk. The nice thing is that when you're doing development, you can use Spatialite. You make a mistake, you just delete the database. Right? No complex statements or anything, no security, nothing to worry about. It's just a single file. Django has a built-in development web server, so we don't need Apache to do our basic development, which is what we're going to use today. We're going to use that development server. I guess I am going over the install of Django. There it is. All right, so obviously you need to choose a database. I mentioned already the databases that Django supports: MySQL, SQLite 3, PostgreSQL. SQLite 3 is actually bundled with Python, version 2.5 and newer. MySQL, obviously, you can get. You need to have the PostgreSQL, sorry, not the PostgreSQL, the Python drivers for whatever database you're trying to use, obviously. But once you've got those drivers, it's just a matter of configuring Django to start using them. Now, like I said, the ORM is totally database agnostic. So if you write stuff today using the ORM, using Spatialite, you can always run it tomorrow using the same ORM with PostgreSQL or with MySQL. Very nice if you want to go out and you want to sell your product and you want to be able to support lots and lots of different databases. All right, so Django is organized at a couple of different levels. The first thing is whenever we're building a new Django thingy, right, a new website with Django, what we're going to do is we're going to use that, or we're going to create what we call a project. Now, if we configure Apache, we're going to tie a URL to that project. So once you go to this URL, bam, you're in the project, and the project handles everything else. But what we need to do is we need to develop, or we need to create a project. And then, the way Django is organized, inside of that project, we're going to include multiple apps. Now, the cool thing about this organizational model is that somebody goes out and they decide that they want to develop their own app to do something really cool, right? Maybe take a web page and, I don't know, load it. And the idea is they want to build an app that does something really cool, maybe something that integrates with Twitter, right? Twitter's a big buzzword these days. So maybe something that integrates with Twitter. Well, what they can do is they can build that app, they can package it up along with all of its models and everything else, and they can make it available to other people. In fact, one of the things that you'll see a little bit later in this tutorial is Django actually has an auth app, something that somebody really smart built to do all the authentication and password management components of Django. The nice thing about that is that you get to skip all the mistakes that you normally make when you're building your own authentication system from scratch, and actually get to use an authentication system that's been tested and people have actually looked at, and so on and so forth. In a lot of cases, when you're trying to develop something, you're going to find an app's already there. So your first step when you're writing Django is to search for an app that does what you want to do. There's a blog app that comes with Django. So if you're trying to write a blog, well, you know what? Django's already got it built in. So the first thing we need to do is we need to create a project. So what I'm going to do is I'm going to open up. Over here, I have a little virtual machine, and I'm going to open up a shell window. Hopefully, you guys can all see this. And the key to starting a new project is using a special command called Django admin. I'm going to go ahead and go over to my desktop so we can just see this on the desktop. And I'm going to go ahead and type in Django admin, start project, and I'm going to call this tutorial. Right? That's it. What I've done is I've created a new project called tutorial. No real feedback here, but one of the things you're going to notice now is that what this has done is it's actually created a package. That package is called tutorial, and if I cd into tutorial, what I'm going to end up finding is there's a number of files in there. I'm going to switch over here to my little Eclipse window here, refresh my desktop, and inside of tutorial, you'll notice I have a couple of things. You'll notice the __init__.py file. It's more or less empty. That's what makes this thing a package, right? So it turns out that projects are always packages in Python. There's a file called manage.py, which we'll talk about in a couple minutes, but it's essentially a nice command line management interface. If I want to initialize the database or push for things from the data model into the database, I'm going to use manage.py. If I want to run a test development server so I can test my stuff, I'm going to use manage.py. Settings.py, as you can probably guess, is actually a list of all the settings that are going to be tied to this particular project. And then finally, urls.py is the start of my URL pattern matching stuff that I talked about a little while ago. Now, once we've created a project, what we can do is we can go right over to that project. Whoops, wrong operating system. We can go right over to that project. Oh, I'm already in the project. And I can say python manage.py run server. Now, when you're developing a Django application, this is probably the most important command you're going to need to run, right? It allows me to actually run the Django development server. Now, the development server is uber cool. It supports a single request at a time, which means that it's great if you're slash-dotted, right? No, obviously not. It's really designed for development only. So the idea is that there's not a lot of security forethought that's put into this development server. You shouldn't run it for anything except for local development. For that reason, it only listens on localhost by default, right? But what I can do now that I've done this, is I can start up a little web browser here, and I can point that web browser to that port. And you'll notice that now I get this nice thing that says, congratulations on your first Django-powered page. Now, one of the things I'm also going to notice is every time there's a request that comes into this development server, it prints out a little thingy, a little line that tells me when the request came in, and some basic information. I did a get of slash. The response was a 200. I think this is the content length, but off the top of my head, I don't really remember. So the idea is that I can see the output. I can see that I got my first page, right? Now, I'm going to leave this development server running. One of the cool things about the development server is that every time I make a change to my code, it watches my code, and it restarts itself. So if I'm in an iterative development cycle where I build something, and then I want to go ahead and I want to restart the server, well, I don't need to restart the server. I just go to my browser and hit reload, and the server will have restarted on its own, right? I'll give you an example. If I go ahead and I just open up my settings.py file here, nope, didn't mean to do that. Tutorial. Settings.py file. I'm just going to go ahead and put a space in here. And you'll notice as soon as I put that space in there, if I go back over to this window, you'll notice that it says validating models, and essentially development server is restarted. So it's constantly going to end up restarting whenever I make big changes. Let's see if this thing will view full screen. No. Man, I hate this full screen thing on the Mac. Okay. So the idea is I make changes, and it's going to go ahead and see those. And there's the run server command right there. It's up and running. Okay, so now I mentioned that our Django applications are built, or our Django projects are built using a number of different applications. Obviously, I need an application to really do anything useful. So the next command that I have inside of my project is the start app command. I'm going to go ahead, and I am going to stop my development server, and I'm going to do python manage.py start project. Start app, sorry. Hello world. Is that what I called it in the, let's see what I called it over here. Yeah, I did call it hello world. Great. Now you'll notice that what it's done in this case is it has created another package here, and that package is called hello world. Now, generally speaking, we're not going to have project-level models, so our models are going to be inside of an app. The idea is our apps should be somewhat modular. We can plug them in. We can unplug them. There may be dependencies on other apps. For example, I might have an app that depends on the authentication components or the auth app. But the idea is that these apps should more or less be plug-and-play-ish, right? So now what I've got here is I've got a number of different things. My init, that makes it a package. My models is where I'm going to define my data models. My views are going to be those functions that handle stuff. And then tests, which we're not going to spend a lot of time talking about today, but that's where I would build my unit tests, because everyone always writes unit tests, right? Yeah, if you write unit tests, raise your hand. Both of you. Wow. I'm just kidding. Unit tests are important, but let's face it, they're a little bit underutilized. All right, now that I've created this particular app, what I'm going to end up doing is I'm going to go over here to my settings.py, and I'm going to install the app, right? Actually, I'm already in settings.py, so I'm going to scroll down here a little bit. And I'm going to go over to where it says installed apps. And inside of installed apps, I'm going to specify the name of my app. In this case, I called my app Hello World. So I'm going to go ahead and put Hello World in there. Now, my project isn't going to use the app. It's not going to look at the app. It's not going to do anything with the app unless the app has been installed. So it's very important that I actually go in and I install the app. Once the app is installed, let me go ahead and try and run my development server again. And it runs. Right? So in this case, you'll notice that it was able to include the app. That's one of the reasons the development server ran. If I had mistyped it, right, like that, and I had tried to run my development server, you'll notice I'm going to end up getting an error, right? So at least this is kind of a very, 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 very basic sanity check for me. Great. So I've got my app created. My app is included. Remember, I mentioned that Django has lots of contributed apps. If you go out to the Django documentation, you can read all about them. Unfortunately, we've only got like 2.5, 3 hours here, so I don't really have time to talk about them, but they're all out there. A lot of them are pretty cool. All right, so let's talk about how requests work in Django. When a request comes into a Django project, what the Django project does is it goes through this list of these things called URL patterns. If we actually take a look at the urls.py file that I had over here, at my project level, you'll notice that right now there are no URL patterns, right? And in fact, when Django's development server is running and there are no URL patterns, it does this neat thing. It prints me sort of this page that says, hey, you know what? You've reached your first Django-powered page. But generally what I'm going to end up doing is I'm going to end up having URL patterns. The idea behind a URL pattern is it is a regular expression. So for example, what I could do is, in this case, you'll notice that if the URL starts with admin followed by a slash, it's going to go ahead and it's going to use the admin's interface stuff, right? We'll talk about the admin interface a little bit later in class, very briefly. But what the admin interface does is it gives me an automatic model management tool, right? So I can see my database and web pages. I can sort on the data. I can see relationships between data, all kinds of neat stuff with a minimal amount of work. So we match these URL patterns. Now in my case, what I want to do is I've created a new app. And what I want is I want that app to be at the very start of my URL list. So what I'm going to do is I'm going to go ahead and say URL. I'm going to have an empty pattern, which basically says anything. And then I'm going to say include. And in this case, let's see here. Hello _ world, right? And there's probably an example over here. Well, this is a basic, this is actually where my URL patterns are, no, sorry, right here. Tutorial.helloworld.urls. Obviously, my URL patterns are going to be in that URLs file. Every entry, do I have an extra? Yeah, okay. So every entry in these URL patterns, right, is going to either be a URL to match, followed by the name of a view that needs to be run if that URL is matched, right? So the idea is that every single one of these regular expressions either maps over to a view, or what it does is it maps over to another set of URL patterns. This include here, right, says that anytime we have a URL that starts with nothing, well, anytime we have a URL that starts with nothing, which is every URL starts with nothing, right? So we're matching the empty string. We're going to go ahead and we're going to pass that over to tutorial hello world URLs. Now the idea is that hello world URLs that we have over here, that allows me to isolate my URL patterns inside of the hello world app. Right now there is no URL pattern file, but what I can do is I can create one. And now what can happen is whenever this URL is matched, it's going to hand it off to the app. Now this is a pretty common technique. The reason is it allows me to isolate my URL patterns within my app. That means that if I decide to pull my app out, all I need to do is go to my project level URL patterns, comment out this line, and those URLs aren't going to work anymore. Or if I want the app but I'm not going to use it, that's okay. I just don't need to have any URL patterns that point to the app, right? So I can use all the neat things that the admin interface, not the admin interface, that the auth components come with, but I don't have to use any of its URL patterns, even though it has very nice pre-built URL stuff for me. Because Django doesn't require that I actually use the URLs from the app. I might want it just for its models, because its models are really nice. And it has lots of neat features otherwise from a code perspective. All right, so what we've got here is we've got this include over to this URLs file. What I'm going to do here is I'm going to go ahead now and go into my hello world URLs. And what I'm going to say is I'm going to say URL patterns equals, and I should have just copied all this, right? And I'm going to have a list of patterns. Now, you probably noticed a couple things already. You'll notice that this is sort of a hierarchical model, right? First it looks at the projects, and then it's going to look at the included ones. Well, it doesn't actually look at them, or it looks at them in the order that it finds them, which means that inside of my project level, if in my URLs at the tutorial level here, I had put in an actual pattern match, and it was before this line here that said match nothing, well, that's going to take precedence, right? Which means that if I, for example, did something like this, or did something like this, only if the URL didn't contain admin/doc and it didn't contain admin/ would it end up getting passed into tutorial hello world URLs. So URL patterns are always processed in order from the top down. As soon as we jump to an include, what we're basically saying is anything underneath a specific URL is going to go to this particular app. I made it very generic because I only have one app. But what I could do is I could do /HW. Whoops. I could do, if it starts with HW, followed by a slash, then we're going to pass it into tutorials hello world URLs. The neat thing here is that if I decide to change what that URL is, it's pretty simple for me to do, right? Just a matter of actually changing where its mount point is, right? So if I have 5 or 6 or 7 different apps, I can use different URL patterns to denote where they are. And of course, you might think, oh, well, how does the app know? If I'm trying to build a template within an app, how does the app know exactly what the URL pattern is or what the URL is to get to this page? Well, a little bit later, we'll notice that Django has some components to use what we call named URL patterns. So I take my URL pattern, I give it a name, and then inside of my templates, I can specify the URL using its name. Django will automatically reverse engineer that URL and put the right URL in there. So if I decide I want to change the way the patterns look, if I decide I want to change where an application actually sits, right, in the URL tree, Django will automatically understand where that is, assuming that I do things the right way, right? And we'll learn the right way here as we go on through the day. So we're going to set up these URL patterns. You'll notice that we have a URL pattern right here. It says tutorial.helloworld.views.welcome. And then it says name equals hello_world-welcome. Now that's the name, right? Now in this case, what ends up happening is when we go to /HW, what Django's going to do is it's going to say, all right, well now I'm going to go into this Hello World app. And then once it goes into the Hello World app, it's going to consider that the HW has been cut off. So it's been removed from the URL pattern. So all I need to do is assume that everything is relative to the root of this app, right? Does that make sense to everyone? It's all relative to the root of the app. I don't need to worry about the HW not being there. The app doesn't know that it's there, right? All the app's URL patterns are going to match this right from the start. So in my case, instead of saying include tutorials hello world URL, what I'm going to say is okay, whenever I have a URL pattern that is empty, so /HW in this case, what I'm going to do is I'm going to go ahead and I'm going to mash that up with something, right? I'm going to say tutorial. Welcome. Great. Views, it's going to be a view. And then I'm going to give it a name. Right? So I'm going to go ahead and I'm going to give that URL pattern a name. Now in this case, what's going to happen is whenever Django sees a request for /HW, it's going to go to this URL pattern file. It's going to find the very first match. And when it finds the very first match, it's going to call that view. Now in this case, that view is inside of my views file. So I go back over here to my views.py. It's empty right now, but I'm going to define welcome. Django.http, Django. Oh boy, lots and lots of. I always forget. Django. Yeah, hey, I was right. Django.http import HTTP response. We'll talk about response in just a little bit, but here's a simple view, right? Now, whenever welcome is called, for any view that we define, the first argument to that view is always going to be what we call an HTTP request object. The HTTP request object is a single object that encapsulates everything that's good about an HTTP request. It encapsulates information about meta parameters, things like your Apache environment stuff. There's actually an attribute called request.post. Well, that's the post data. There's request.cookies. That's the cookie data, and so on and so forth. So this request object is the object that contains all of the information that we need to glean what the client is sending us, right? Both actual information the client's sending, as well as implied information, which would be information like the remote IP address, which would be stuff that would actually come from Apache, right? So all that information is available to me inside of this request. Now let's go ahead and try this. I saved this view. I said hi there, right? Over here I've got my URL pattern. So what's going to happen is a request is going to come in to my test server. If there's nothing there, I'm probably going to get an error of some sort. So let's go ahead and do our first little test here. Run server, got my server running. I'm going to make the same request that I made before, and you'll notice that it says, hey, look, page not found. That makes sense because there is no page. I don't have a URL pattern defined here for the slash, probably something I should consider doing. If I do a /HW, you'll notice that it runs my view, and I get my output that my view was generating called hi there. Does that make sense to everyone? So the idea here is very, very straightforward. We match these URL patterns up to views, and once we match these URL patterns up to views, the views run. But what if I wanted more useful information, right? Obviously, the information that I'm providing right now is pretty basic. What if I wanted hello world, and then I wanted someone to enter their name because I wanted some sort of name-specific URL? Well, that's where regular expression pattern matching comes in. The idea here is what I can do is I can start putting in patterns. My favorite pattern looks something like this. Looks something like that, right? Or maybe something like that, right? So in this case, can anyone tell me what this regular expression means? Is anyone here familiar with regular expressions in Python? All right, so the first thing you'll notice is that this question mark P thing right here, followed by this name in the angle brackets, that actually is what we call a named match. What's going to end up happening is when a match occurs, whatever matches what's inside of these parentheses, whoops, and I'm missing a plus sign here, missing a plus sign there, whatever happens inside of those parentheses is actually going to get thrown into a variable called name. Now that variable is actually going to be passed into this function as a named variable. So the idea is whenever I capture something in a URL, it's either going to be passed in as a positional variable into that particular function or a named variable into that particular function. I like to always use names, so you're never going to see me do anything that's really positional. What you're always going to see me doing is you're going to see me doing these things where I name things. So that's what the question mark P in this does. In this case, the expression itself is it says any character that's not a slash any number of times. So what I'm saying is match everything from this slash to this other slash as many times as it appears, right? Or as many characters as it goes. So now, what ends up happening is when somebody actually uses this URL, they're going to put in HW/name, being whatever you want, and that name value is going to be passed right into the view. Now, of course, my view needs to know that it's going to accept a name, right? So what I'm going to do over here is I'm going to say name as a named argument. And then over here with this hi there, I'm going to go ahead and say %s. And I'm going to substitute in the name, right? So there we go. Let's go ahead and run this. Whoops. Page not found because I didn't put anything in. I'm going to put my name in, and you'll notice that now the output that I get is hi there, Chunder. Everyone see this? Questions about this? Now, your sky's the limit as far as these regular expressions go. You can make them as complex or as simple as you want. You can make them match hundreds and hundreds of different things, right? You could say name, and then you could say last name, last name, birth date, and so on and so forth. As long as you can write a regular expression that handles it, you're good to go. So if we think back to that blog app that I was talking about that Django provided before, maybe there's a regular expression in there that has a four digits which it uses for the year, and then it has 2 digits that it uses for the month, and then 2 digits that it uses for the day, and it passes that in to the view, which then goes and looks up the blog entry for that particular day, or the blog entries for that particular day. Now going back to our regular expressions, right? So that was kind of the short and quick. URL patterns can be named. The same example that I did right here, welcome name, is right up there on the screen, right? So it's in your slides as well. And so the idea is we can take this a step further and a step further and a step further. Here you'll notice that we have a second named pattern called hello world welcome name age. But you'll notice that it actually handles or hands it off to the exact same view. Well, one of the things that we know about Python, or we hope we know about Python, is that we have optional arguments. Right? We have optional arguments. I'm going to go ahead and say something like if age is none. We're going to go ahead and do that. Else, return HTTP response. Eclipse tries to help me, unfortunately. Right, so I can do something like this. Now, these things that are matched in URL patterns are not cast over to different data types, right? And that's why in this particular case, I'm assuming that age is a string. Didn't do a %d there because I hadn't cast it to a string. I can guarantee more or less that it's going to be a particular value. Right over, nope, URLs. I can go back over here to my URL patterns. Copy that in there. Welcome age, and then over here I could say, oh boy, what? Oh, I'm at the, what did I do here? Did I do this at the project level? Oh, haha, I didn't mean to do it there. Sorry about that. There we go. Slash. Great. See if I can collapse this down a bit. Tutorial equals hello world views welcome. Name, and now what I'm going to do is I'm going to say \d plus slash, right? And I want to capture that. So I'm going to put it in parentheses, and then I want to give it a name. So I'm going to do something like that. And so now, if I save this and I run it, that works the way it did before. And obviously something's wrong here. My view, oh, age equals none. Name slash \d plus. You are right. What I need is a $sign here. Good call. Yep, I was missing the $sign there. Obviously I got something wrong here. Chunder /34. Let's take a look here. We've got name. We have age. What did I have wrong there? HW Chunder 34. Oh. It's passing in the age as the name. No, it's an optional argument to the view. Right, so in this case, what it should be doing is it should be, there's something wrong with my pattern here. It's, luckily I have an example to work from over here, right? I don't know what's wrong. I think that might be a typo, actually. You can try it with the dot, but I think that's a typo in the slides. Yeah, the dot's going to match any character. That's actually a typo in the slides. You guys can cross it out in your slides. I'll have to come back to this and see why this isn't working. You know, it's slash age \d plus. Views welcome. Hello world views welcome. I'm sorry, what was the question? That's right. I need to match from the start of the URL pattern. That's something that's actually pretty important, right? If I don't match from the start, it's going to end up matching at more or less wherever it finds a match. That first expression was actually matching in this case because it was matching the first part, and that was a problem for me. So there we go. Now it's working. Thank you very much to whoever it was that said that. Okay, so the idea is we build these URL patterns. When we build these URL patterns are going to match whatever we want. Obviously, regular expressions are complex, as we just saw. Because those regular expressions are complex, we want to make sure that we test them to make sure that they're correct and we're not missing characters and whatnot. The idea here between matches is what ends up happening is when we match that first regular expression, right? What ends up happening is that the named argument gets passed into the function. Because I define the function so that some arguments are optional, I can call it lots and lots in different ways, right? Lots and lots of different ways. And if I really wanted to get complex, I could take that view and I could make it so that it accepted, you know, arbitrary arguments or an arbitrary number of arguments and have things be sort of really dynamic, right? By using something like star KW args or, you know, something along those lines. All right, so we've got these URL patterns. These URL patterns, obviously, we can make them as complex or as easy as we want. If we're using things like the auth contrib app, you know, things like that, what we can start doing is we can start either defining our own patterns that point to other apps. So rather than using maybe that app's built-in views or built-in URLs.py, I can define my own URL patterns for them. Obviously, I'm going to want to name them so I can reference them in other things. Couple of things here. You'll notice that before when I was defining patterns, what I was doing in my patterns was I was saying, in every single one of these, I was saying tutorials.helloworld.views.welcome. Well, one of the techniques that I can use is this first argument to patterns can be the base part. So rather than me having to say tutorials, hello world, views, welcome, I can go ahead and just say tutorial, well, I can just say welcome, right? Just reduces the typing that I need to do slightly, right? It also makes it easier if I need to change where this is or the name of the app or something like that further on down the road. And of course, I need that extra colon in there. So I can use these nifty URL patterns. We can write patterns that use default arguments. So one of the things that I can do when I'm actually writing these things is I can go ahead and the second argument or the third argument to that URL function can actually be a dictionary of default arguments that are passed into the view, right? So what I can do, if I go back to my example right here, I can say something like age older than you want to be, right? I could do something like that. Now in this case, when somebody calls this URL pattern, or when this URL pattern gets matched, what it's going to end up doing is it's going to end up passing a default string in for age. So now, if I go back and I run this thing, and I leave off the age, what I end up finding is it says, hey there, Chunder, you are older than you want to be, right? So the idea is I can put these default arguments in, so I can make these URL patterns, you know, in some cases I can make them very static, in other cases I can make them extremely dynamic. The idea is that, you know, if I have two views that are going to do more or less the same thing, you know, just adding another argument in makes it pretty easy to do. And Django actually provides a number of cool tools to automatically, you know, for example, if I just have a template that I need to render, Django has a very generic template renderer. So rather than me having to write a whole view and maintain it to render a simple template, which you'll see later, it's extremely easy to do. I can do it using a method like this. All right. Django views are always going to do one of two things. They're either going to return an HTTP response object, or they're going to raise some sort of exception, right? Generic exceptions that are raised inside of my view, when I'm in debug mode in Django, which is what we're using right now, what we're going to end up finding is Django is going to give me a nice page with a nice stack trace on it. So I can look at this stack trace and look at exactly what went wrong. In more of a production environment, the default for Django is to send an email, right, to the owner of the project to say, hey, look, we had an exception that occurred, along with some information about that exception that occurred, usually a stack trace. But inside of my Django application, I want to handle most of the common cases that I'm going to end up seeing. So for example, if I don't have a match, right, with the URL patterns, the user is going to get a 404, right? 404 means we get all the way to the end of all of our URL patterns, and there was no match. Right? On the other hand, let's say that I had something that happened inside of my code. Maybe what I wanted to have or I wanted to see is I wanted to see that the user was coming from a specific IP address, specific remote IP. And so what I'm doing is I'm looking at request.meta, I'm looking at the remote IP, and when I look at the remote IP, I'm going to match it against some regular expression. And if it doesn't match against some regular expression, I want to give back the normal sort of HTTP error code. Well, for that reason, Django has a couple of children of the, children of the HTTP response objects, so subclasses, and those subclasses do lots of cool things. If I create an HTTP response not found, it's going to return a 404 page. If I return a HTTP response server error, right, it returns a 500 status code. So rather than me having to set these status codes on my own, right, I can use the Django ones that are sort of built in that do the work for me. Now that actually brings us to an important point. One of the things that I showed you a minute ago was I showed you that inside of our views, what we could do is we create these HTTP response objects. Now the cool thing is these HTTP response objects are like Ginsu knives, right? They can do all kinds of cool stuff. The first thing is that if I wanted to create an HTTP response object, I could say something like response equals HTTP response, and I'd create an empty response object. Now once I've got that empty response object, I can write things to that response object if I want to, and that'll write to the output, so it'll accumulate that information. But more importantly, and what's of interest to me, is I can treat the response object as if it's a dictionary. If I treat the response object as if it's a dictionary, those are going to set headers, HTTP protocol headers. So if I wanted to have a special header that said, you know, X something, I could do something like that. And if you have something like Firebug that's open, right, you can actually see that inside the headers. That's assuming that we were returning those response headers, right, which we're not in this case. But the idea would be that we have the ability to see them. So we can set protocol headers by treating the response object as if it's a dictionary, right? And of course, by writing to the response object or by passing an iterative object into the response object, we can end up having the response object generate its output, right? Is anyone here familiar with the concept of a generator? Yeah? One of the common things that we'll do is rather than having all the work done at once and put into this response object, we'll pass the response object to generator. That way, as it's generating the response, Django code can actually run to generate that final output. Right? So generators are another cool way that we can take advantage of sort of doing the work just in time as the data is being returned, so we don't need to buffer nearly as much information. Okay, so we've got these special views. Now it turns out that Django's here's some of the stuff that I showed you actually, or I talked about on the previous page. So here from Django HTTP, we're going to get response, and we're going to get response forbidden. If the age is less than 18, obviously, this is like a tobacco selling site or something like that. And so what I want to do is I want to give a response forbidden. On the other hand, otherwise what I want to do is I want to say, hi, are you whatever age, right? So I want to generate, a very basic response. Now in this case, you'll notice that I used the write method. I treated it as if it was a file-like object, so I could write information to it. When I created it, I didn't pass anything in. I just created an empty response object, and I wrote information to it. So these response objects, I can create them with data. I can go ahead and treat them as a dictionary once I've created them. I can go ahead and I can write into them as if they're file-like objects. I can pass them things like generators, and they'll actually iterate over the data as they're producing the output. If you're familiar with, and then here's an example, XPython header, that pair is definitely dead. Silly Monty Python reference. So here we have an additional header that's passed out. And then otherwise, we're going to just go ahead and return a simple HTTP response. So the idea is you can create these things at the start. You can walk through your code, write to them when you need to, if you need to. Now the fact of the matter is we're learning all about this cool HTTP response thing, but most of the time when we generate output in Django, we're going to do it using a template, right? The notable exception, or the most notable exception, would be in the case of something like an API, where what I wanted to do was I wanted to return a JSON object or a JSON response. Right? Turns out that one of the things that I can do when I'm creating an HTTP response object is as a second argument, I can pass in some header information, or well, some basic header information that HTTP response understands, something like the content type, right? So if I was returning JSON, I could say, content type equals, return some JSON, right? Now, if you're familiar with mod WSGI, you should see some parallels here, right? There's a lot of similarities in the way things work with respect to mod WSGI. And in fact, one of the common deployment strategies for Python, which I'm sure they'll talk about in the next talk about Django, which some of you are probably going to, is mod WSGI deployment. So some neat stuff. All right, so before I start talking about templates in Django, any questions just in general about this first set of topics? So the idea is the request comes into Django. Django uses a bunch of URL patterns to match that request to a view. And then the view creates an HTTP response object or a variant of an HTTP response object, which it returns to the browser. And that's the end of our entire request response cycle, right? End to end. Now, obviously, we don't want to have a variable that contains a whole bunch of stuff, or we don't want to build these really, really complex views that have all this code. Obviously, if you wanted to do that, you'd be taking a PHP tutorial, not a Python tutorial. What we really want to do is we want to go ahead and we want to create these concepts or these things that we call templates. Now, the idea behind a template is it's just that. It's an HTML file for the most part. It could be XML. It could be CSS. It could really be whatever you wanted it to be. It could be a PDF template, and you use something like, PDF TK to merge variables into it and generate output, or you generate an FDF file and do a merge, whatever. Django doesn't natively support PHP templates. It has its very, very specific templating language, and that's what we're going to learn about here. But the idea is that, generally speaking, your views are going to be fairly lightweight, and they're going to use these templates to generate most of their output. So in this case, what's going to happen is when our view gets called, we're going to assign a bunch of variables inside of our view. For example, maybe what I'm going to do is I'm going to go back to what I had written just a couple minutes ago over here in my view. And rather than saying welcome response equals HTTP response, I'm going to get rid of all this. And I'm going to say data equals age, name. Great. So now what I'm doing is I'm setting up a dictionary, right? And that dictionary basically contains information that I want to be available for substitution inside of a template, right? Now, templates are basically HTML files. We're going to learn about them in a little bit. But one of the things that we need to know is that we need to load these templates. Now, it turns out that Django has lots of different ways that we can render templates. But the most common method that we tend to use is a shortcut method called render to response. Now, as you might imagine, what render to response does is it takes a template, it's going to take some context information, or the information that will be put into the template, right? Really, that variable that I called data is probably better named context. And then what it's going to end up doing is it's going to render the template. No, I'll say welcome.html. Right, so I'm going to do something very simple like this. I call render to response. I say, hey, here's the template you need to use, and here's the information that needs to be substituted into that template. And what it's going to end up doing is it's going to load that template up. It's going to iterate through that template. It's going to find those variables, right, which are specially denoted. And then it's going to go ahead and do the substitution for me. And when it does the substitution, it's going to generate this nice output. Now, obviously, in order for this to work, what I'm going to need to have is a template. So I'm going to go back over to my app. I'm going to create a folder inside of my app called templates. And then inside of my app folder, my templates folder, I'm going to go ahead and create a file called welcome.html. And I'm going to open up welcome in a nice text editor. And I'm going to say, hello, name. Now we'll talk about some of these template variables that I'm using here in a little bit. But let me run a quick test and make sure that works. Hey, it worked. Right? Rendered the output using the template. I'm going to go over here and I'm going to say in the template. That way you can actually see that it's really coming from the template. There's the output, right? So let's talk about how this works, right? First of all, context variables, right? That context that I sent in, those context variables are sent in as a dictionary. Now the keys are going to be what I'm going to reference in the template. Age, for example, is a key that I'm referencing inside the template. Name is a key that I'm referencing inside the template. So what I'm doing is I'm able to reference these things, and what it's going to end up doing is it's going to end up taking the value and it's going to stick it there. If the value in the dictionary was, for example, a object, right? What it would do is it would return the string representation of that object, right? If it was a list of values, I could reference elements in the list using this sort of notation, right? So in this case, what I did is I provided it with a list, and now, if I save the template, oh, I did save the template. What did I call it? Stuff 012. Oh, obviously there is no 3. Probably help if I use a valid value, but there you go. It prints out pair at the end there, right? So the idea here is that I can call methods of objects, right? I can pass in, using this period notation, the methods of objects. I can pass in indexes in lists. I can pass in keys in dictionaries, right? So the idea is that this period notation allows me to do lots of neat lookup things. And as you can probably imagine, just like I use the if statement here, there's the concept of a for loop inside of a template. There's the concept of if statements inside of a template, and so on and so forth. So all these standard concepts that you're probably used to seeing in something that's more or less Pythonic, or in Python, we have access to within the template as well. So we can do all kinds of cool stuff. All right, so let's head back over to slides here that we were talking about. So we were talking about templates. The idea is we have this variable, this context that we use for variable substitution, right? Contains key value pairs. And what's going to end up happening is it's going to go through and it's going to iterate over those things and do the substitution for me. Now, it turns out that this was all really magical, right? And the reason it was really magical is all I did was I created that template file. Django found the template file. It loaded the template file up, and wham, it was there. It was beautiful, right? Now, it turns out there's a bunch of cool things that happen behind the scenes to make that happen. First of all, inside of Django, in the settings file, there's this thing called template loaders. And what the template loaders basically does is it's a bunch of functions or objects that it calls, and those objects are designed to go and find templates, right? They use a very, very specific formula, right? Template loaders, app directories loader says, okay, for the app that I'm currently running, I'm going to look at the app that this view is defined in. I'm going to go ahead and I'm going to look in a subdirectory called templates for a template of that name, right? And then file system loader actually looks at a setting in your settings.py called template dirs, and it searches that template dirs directory. Now, if you want to organize these templates, you can use subdirectories and whatnot. It's just a matter of when you use render to response, you would specify subdirectory name / template name and so on and so forth. But the idea is Django is going to locate the templates for you. Right now, we're not doing anything special with template caching or anything, but Django has components to cache templates for you as well. So if you're talking about a template you're rendering very frequently, you can do things like caching. Django has, generically speaking, cache components as well, where if you have a template that's rendered, let's say that you're a newspaper site, and 95% of the pages that you render are the static for 10 minutes. Right? And then you have new news stories that come in. Well, you can do things like cache a views output, right? So rather than you having to run the view every single time, it can grab that cache information and send it out. There's lots of cache components. We won't have time to go into them here in this tutorial, but they're there, they exist. If you go out in the docs, all that information's there as well. Right? So there's a file system loader. The idea here is that what it does is it looks in the file system template dirs first, and then it looks in the app directories. The cool thing here is that if you have an app, right, and you want to override its template, you don't need to go and modify the app, right, or the app's template. You go ahead and you put in your own template that overrides the app's template, and then all you need to do is worry about having your templates there. Right? The idea really is that we don't want to go modify somebody else's app. What I want to be able to do is use it, and then when they come out with a new version that fixes all the bugs from their previous version, I can just plop it into place and find that because I'm using my own templates that are maybe based on theirs, everything is kind of copacetic. There's also these things called static files. As you're probably familiar with, most of the time when we have web pages, what we end up having is obviously this dynamic content, and then we have these static things like CSS and JavaScript and whatnot. Once again, Django has methods to where it can include some of those things for us, or it can include a URL to those things, which is what we usually end up doing. Right? We'll have Django generate a URL to where our static media is, and then we have a folder where we stick that static media so that everywhere inside of our pages we can reference that static media. We'll learn more about that as we go through here in a little bit. All right, so here's my classic example of a Django template, right? So the idea is here's my template. My template has an example of lots of cool stuff. There's a list. There is a object. There is a dictionary, right? And then what we end up doing is we end up passing that context in to render to response along with a template, and it's going to go ahead and render that. Now, if the template, generally speaking, the template's pretty smart. If the template tries to reference a template variable and it's not defined inside of the dictionary, what's going to end up happening is it's going to be replaced with nothing, right? We saw that before when I used age.3, right? When I used age.3, there was no element 3 inside that list, so it just blanked it out, right? So the idea is that we can build our templates so maybe some things wouldn't be there, which is fine. Django doesn't have a problem with that. Static files. So inside of our Django code, right, we talked about this static stuff. If we want to, what we can do is we can put static files inside of our static directories, which we define inside of our settings file, and then we can reference those static files using something like this. In this case, static URL ends up getting replaced by a URL setting that's in our settings.py that points to where this static media is. That way, what we can end up doing is we can, with our development server, actually, when the development server is on, Django will automatically serve up this static media if it's on the development server. And then Django actually has utilities to pack up all the static media for deployment to a different server. Obviously, in a production environment, you don't want Django to store or serve up all your static files, because that just means you need to pass through this WSGI app or this Django application to go out and to serve up all these files. What I'd like to do is put them somewhere else that Apache can serve, or even on a separate server altogether. That way I can get better parallel calls and things like that. All right, using that same dictionary I showed you before, here's a sample template, right? The sample template is essentially loaded up here. Here's the HTML for that template. Simple variable month we can throw in there. If we wanted to call a method of an object, what I could do is I could go ahead and use now. It's going to go ahead and call the method that date time object here. Dictionary lookup, right? So there's the key there, name.jones. Jones is the key. That's going to print out Alan. And then finally, if I have a list, I can go ahead and do a lookup in a list, right? People.0, element 0 from that list, which in this case is Joe. Questions about this? So we build these HTML templates with all these nice variable substitutions, right? Usually you're going to go off and somebody who's actually good at web design, which could be you, it's definitely not me, is going to go out and build these things. You're going to templatize them, and then Django's going to substitute in the values. Question, Brandon? Well, you don't. Well, you look at the output, right? And the output says, hey, look, it's not there, right? There are some debug tools that you can put in, that you can turn on, that are available. I don't use them very much, so it's difficult for me to say whether or not they'll tell you that, but I suspect they would, right? They would tell you about variables that weren't defined. There's debug. All the queries, when we start using the ORM, debugging will log the queries that happen against the ORM. And there's actually template variables that are available to you where you can look at that debug information. The other thing is there's a really cool add-on. There's actually lots and lots of add-ons to Django. One of them is called Django Debug Toolbar. And the debug toolbar is really cool. If you're coming from one of these admin IP addresses, it'll go ahead and give you a nice bar on the side that shows you things like execution time and queries and errors and so on and so forth. But the real answer to that is you want to use the debug tools to get that sort of information. Other questions? All right. So what we've done so far is we've looked at some very, very generic Django template stuff, substitution. But it turns out that the way Django templates work, and is anyone here familiar with PHP's concept of Smarty templates? There's a lot of similarities there. The first thing is this concept of filters, right? A filter is essentially like a function that you're passing a value into. We can chain these filters together. Some of them accept arguments as well. But the idea is that if I want to take a particular variable, convert it to lowercase, then capitalize it, I can use filters to do that. Now, I don't have a copy of this for you guys, but it's out on the web. There's this neat Django version 1.3 cheat sheet that's available out there. It's at revsys.com. Actually, if you just Google Django 1.3 cheat sheet, you can actually get this document. It's free. I don't want to put it in the slides because there's actually no copyright information that's listed on here. And I didn't have time to go and ask the authors. But the idea here is that you can go out, you can download this thing, and and things like filters and tags, they're available and they're documented inside this cheat sheet, right? And as you can see, there's probably some 30 or 40 odd filters that you can use. There's also lots of filters that you can add on your own. So it actually has a loading mechanism where at the top of our template we can use this special load template tag, and it'll go out and it can load our custom filters for us. So if you have a filter that's supposed to contain, or that's supposed to change a color into, or a number into a hex, its hex value, right? There's probably something that already does that, but you could write your own template tag to do that, or your own template filter. Now, the other concept that's important to understand is there's this concept of template tags. Template tags are things like looping tools and whatnot, or the ability to include one template in another, or have a template be built off another template. Template tags are a little bit more complex. They typically have things like begin and end sections, like for example, I thought I had a for loop example up here. I have a for loop example over here on the slides, right? So, no, I don't have a for loop example on the slides. All right, well, in the case of a for loop, I think I put one, or an if statement. I guess that's what I was talking about. In the case of an if statement, which I have right here, right, that's what we would call a template tag, right? And the idea behind a template tag is it's a little bit more complex in terms of program logic, but allows us to do things like decision processing within our templates, looping within our templates, finding out where we are in loops, doing loops within loops within loops within templates, doing key value pair lookups, so we can use the standard sort of Python for loop inside of a template to get keys and values. It's actually done using what's called a for each statement inside of a template. But the idea is we have access to all of these language, Python language type things right within our template. So we can make our templates, rather intelligent. All right, so I talked about filters. All right, template tags. So these next set of slides, 31 until whatever it is that we end here, not the class, but this set of slides here, talks about our template tags, right? And so the idea is that these tags typically evaluate some sort of variable. That variable is going to be evaluated in a true-false type context, right? You can use the equals statements, your standard sort of Python comparison type tools here, but it's going to evaluate it, and then it's going to return us a result. If tags actually allow us to have else's, and they always end with end ifs. Now, one thing where the template system is going to be fairly restrictive or fairly strict is if, for example, you start a tag and you don't end it, right? So, for example, if I start the if and I don't put the end if in there, or if I have mismatched ifs and end ifs and so on and so forth, that's where the templating language is going to start throwing up more along the lines of template errors, right? If something's not there and you're trying to substitute it in, Django doesn't really care for the most part. We have for loops, right? So there's an example of a for loop. Pretty straightforward. That cheat sheet, which you can actually go out and download, hopefully a lot of you have already pulled it up if the internet's working here today, is available. It's got lots of cool stuff about that. Inside of for loops, we have the ability to figure out what loop, how many times we've looped through it. So if you're doing something cool like non-CSS zebra tables, right? You can use this for loop information to figure out, how many times do I have left to go through the loop? How many times have I been through the loop? Am I at the first loop or am I at the last loop? So that might be where you put in your UL tags and your /UL tags, right? And my last time I'm going to close out this particular loop, and so on and so forth. And then, of course, if we have a loop within a loop, the loop will have a parent loop attribute. And then if we have a loop within a loop within a loop, we would use loop for loop.parent loop, and so on and so forth. So even when we're nesting these things, I can figure out whether this is my first time through, my last time through. So I can generate large and complex things like table structures just by using these sorts of for loops inside of templates. All right, so we talked about basic templates. Now, one of the things that your app, I know, is going to almost always want is the ability to have stuff that's always there inside the template. Maybe stuff like company information. Maybe you work for one of these companies that every couple months gets sold to somebody else. We'll say MySpace, for example. Just kidding. But the idea is you got one of these companies that gets sold from time to time, or maybe the expectation is you're building the company to be sold, or you're with a startup. Obviously, this is the Bay Area, so it's the place for that kind of thing. The idea would be that we're going to want to not hard code everything into our templates, like company name, right? That might be something that I either put inside of a template that's inherited elsewhere, or it might be something that I actually put inside of a variable that I want to be used everywhere. right? So I want every single time I generate a template, I want these 5 or 6 or 7 or 80 different template variables, I want to always be there. That's where the concept of context processors comes into play within Django. The idea behind a context processor is that what it ends up doing, so we say context instance equals request context, it ends up calling a bunch of functions, and each of those functions return a dictionary that gets merged into the current context, right? Now, Django has its own set of default context processors that we can use that'll do things like take information inside of Django settings and make it available in the template. Or if I'm using the auth module, take auth or account information and include it as a set of variables inside the template, and so on and so forth. Django has some default context processors that are on by default, but we can also augment them with our own. An example here is we have a view, but anytime this view generates output, we want to have whatever the view gives it for the template, along with all of these other context processors. In this case, site context is the context processor that I'm most interested in. So the idea is these context processors are essentially functions that are called. They're passed in HTTP request, because with HTTP request, they can glean other information about the request or what's going on. And what they're going to end up doing is they're going to end up augmenting that context instance, that context, which is then passed into the template for rendering. So the idea is this is a chain of functions that can allow me to build a bigger and bigger and better sort of context dictionary that I'm then going to end up passing and using as using inside of my templates. Now, if I go back over here to my views, what I can do is all I need to do here is say context instance equals request context request. Now, it turns out that Django has some default context processors, but those default context processors aren't actually loaded unless I use request context, right? Or unless I use this context instance thing. So most of the time when I use render to response, I'm going to use it just like this, right? Now, obviously, I don't have request context included, so I'm going to say from Django.templates, import request context. And now what's going to end up happening is additional context is going to get added before that template is rendered, right? Just like you see here. Now, if I want to, for this particular instance, also run this site context processor, my special context processor, I can do that as well. Or what I can do is I can create my own file full of context processors. And inside of my Django configuration file, there is a setting called template context processors. Now, what you've got up here on the screen is Django 1.3's default list for template context processors. If you go into your configuration file, your settings.py right now, you'll notice that it's not there. The reason it's not there is that the default is the default, right? And if you want to change the default, what you're going to end up doing is you're going to copy this block of code. You're going to go out to the Django docs, and you're going to find the block of code that's there for the current version of Django that you're using, and you're going to go ahead and add it in. Static. A couple of minutes ago, I talked about static URL. Well, you know what? If we're not using context processor static URL is probably not going to be available to us. So the idea is that different components are going to be there. Obviously, there's a debug one, so we can reference debug variables or debug information. There's an auth context processor that's in there. So when we're using Django's authentication systems, it's going to end up using auth, and so on and so forth. So media defines a bunch of media URLs. That really has more to do with like files that are uploaded by people into the system. So uploaded files as opposed to files that are more or less static. Django with 1.3, with 1.2 they used to be commingled. With 1.3 they're separated out very, very nicely. The static stuff is this stuff that should never really be changed by the user or should never be created as part of the application. Instead, when the app's running, people do file uploads or you're creating files. That's where we're really going to talk about, or we're really talking about media type information. All right, questions about templates. Now, as you've probably surmised at this point, we've been going over all the easy stuff first, right? Django views, URLs, templates, those are all the basic bread and butter. If you've used any other sort of web development environment, you're probably used to some of these concepts, right? Or at least one or two of these concepts. The real meat of Django really starts coming into play when we start talking about using Django's models, Django's forms, and some of these other tools like the administrative interface that Django provides us with. Obviously, so far what we've talked about could be used to build a really nice static site that never changes, but these days, whoever creates a static site that never changes, right? What we're going to want is we're going to want a really cool dynamic site that has data inside of it where people can put stuff in and we can get stuff out. And that's really where the concept of the model comes into play. Now, Django's modeling language allows us to represent information that's stored in the database, right? But using standard Python techniques. The place to start here is if we take a look at our models.py file. Now, our models.py file is going to be defined on a per app basis. When these get persisted into our database, what we're going to end up finding is that for each of these apps, or for each of these models, it's going to use a naming strategy that includes app name underscore model name, right? And so the idea is that even if I have 5 different apps that use a model called content, right, they're not going to collide because they're app-specific naming strategies. One app can reference another app's models. So for example, let's say I have a blogging app, and I want that blogging app to be able to have users authenticate, but I want to use Django's auth components. So whenever a new entry is created, I want to link over to the user record that created that entry. That way I can make sure that one person doesn't modify another person's content, right? Blog content. So in that case, I can use references. The modeling language supports things like many-to-many relationships, foreign keys, primary keys, nulls and not nulls, values that are required inside of a data model, and so on and so forth. And it's all done using this ORM wrapper. Today, we are not going to write a single line of SQL code, right? And as soon as you start using Django's ORM and you start writing SQL code, that should sort of be a little bit of a red flag to you that says, you know what, I may have just lost my portability. Usually, if you do everything within the ORM, what you're going to find is that you're 100% portable across all of these other different databases that Django supports. Okay, before we can actually start using Django's data modeling components, what we need to do is we need to configure our Django application for the database we want to use. Now, one of the things that's really neat about Django is Django supports multiple backend databases. Now, what does that mean? That means that what I could have is I could have a read-only database server or 30 read-only database servers, and I could have one read-write database server, right? And Django actually has this concept of database routers that we can use to route requests amongst them. So if I have a view that's doing a write operation, it gets routed to the write database server. And if it's doing a read, it gets routed to the read database server. And maybe I'm using Postgres, and I've got synchronous replication running across my one read and my one write server. And so I've got this really cool environment where I can offload a lot of my read load just by routing things correctly. So Django supports this. We're not going to talk about it at all in this tutorial. But you can go out to the docs and you can read about it. Now, that's the reason why here in this databases dictionary, what we have is we have a subdictionary, right? Every single one of those, or every single subdictionary is going to reference a named database connection. In this case, the default named database connection is default, right? And that's why we see default in here. Now, the first thing we need to do is we need to specify the database engine that we're using. In our case, we're going to use SQLite. So what we're going to go right here, and we're going to say SQLite 3, right? And you'll notice there's a list, right, of the supported ones. PostgreSQL, MySQL, SQLite 3, Oracle. The two, PostgreSQL PsychoPG2 versus PostgreSQL, that's just a different driver, right? I like to use PsychoPG2, but there's another PostgreSQL database driver that exists, so you can choose which one you want. Now, generally speaking, if we're connecting to a database like Postgres, we're going to need to have a bunch of credentials, right? And that's really what all this other information is about. In the case of SQLite, what we're going to have is we're going to have the file name, right? Tutorial.sqlite3 is what I'm going to call my database file. So in this case, it's just going to go ahead and put it in the current directory, and it's going to call it tutorial.sqlite3. Simple. Questions about this? Nope. All right. Great. So now we've got our database configured. All the other stuff is in there. Now let's go ahead and make sure our database works. Now, one of the neat things that Django provides us with, besides just the admin interface with that manage.py thing, is it provides me with a cool shell. Now, this interactive shell allows me to basically run Django code, use my models, the ORM, all the other stuff directly inside of an interactive Python console, right? So if I'm trying to test a view or if I'm trying to run a query against a model, what I can do is I can start up this console and I can go ahead and run my queries right here inside of my development console. Now, in this case, what I'm going to want to do is I'm going to want to make sure my database connection's OK. So I'm going to say from Django.db import connection, and then I'm going to go ahead and say cursor. And I have a cursor, right? That's really all I'm trying to test here, is that I can get a cursor. That tells me that I'm able to connect to the database successfully, blah, 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 right? So it's able to connect and do all the stuff that's required in order to get a cursor. Now, as you may have surmised, what I've done in this case is I've actually gotten an actual database cursor, right? If you're familiar with the Python database API version 2.0, right, you're probably able to run queries, create tables, do all kinds of neat stuff just by having this cursor. But resist that temptation. Obviously, Django's ORM is the way to go. If you start writing stuff using these cursors, things can get a little bit funky for portability's sake, right? Great, so now that I've actually defined a database for myself, what I can start doing is I can start defining models. This is where the fun stuff comes in. Great, the first thing is that all the models that I'm going to create in Django are actually going to be coming from a model object that Django provides me with. Right? That model object, or the base model object, is inside of DjangoDB.models, right? And it's called model. So anytime I create a new object, it's going to be a subclass of the Django model. Class. And what do we want to do? We're going to go ahead and call ours, I must have an example that I'm using here. Hey, I called ours events. All right, so we're going to go ahead and create one called events. And in this case, models.model. In fact, I'm going to call mine event. Models.model, right? Now, generally, the standard is to use singular names. Django will automatically try and pluralize them for you, sometimes with really odd results, or really odd, depending on what your model name is. We can define our own plural names if we want to. But in this case, event's going to be the name. Now, in this case, my app is called Hello World. So when this gets pushed into the database, what it's going to end up doing is it's going to create something called Hello World underscore events, right? Or sorry, Hello World underscore event. The reason I'm using singular is that each instance of the model is going to represent a single entry in the database, right? So if I have 5 event objects, those 5 event objects represent 5 rows in the database that I can then manage and manipulate using the ORM. Great. So what things might we have associated with the event? We might have a start date. And that's going to go ahead and use models.datetime field. And great. Now, if you go back into the cheat sheet that I talked about a little bit earlier, you can see what some of these fields are. Essentially, what we've got is we've got a bunch of fields. These fields map over to essentially equivalent fields inside the database itself. So date time field is going to represent maybe something like a date time field inside of the database, right? Car field, for example, right, is going to represent a character field. Now, with each of these fields, we're going to have a bunch of options that we can use, right? In this case, required equals true means that it's a required field, right? So we can specify all this kind of stuff. You'll notice that one thing I haven't done is I haven't designated a primary key field for this particular object. It turns out that Django automatically creates primary key fields for every single one that's called ID unless I specify my own primary key, right? So ID is going to be created there. What else do we want? We want maybe an end date. And we will go ahead and say that's it, right? Yes? Nope, it's created automatically. Yep. And one of the things that we can see is we can see what the SQL looks like, right? Great way to actually show that. If we go ahead and say SQL all, hello world, right? The SQL all command for manage.py will essentially dump the SQL that would be created or used to create this thing. And required equals true is not the right one. That's for forms. Null equals false is what I want. So not null. There we go. So now you'll notice when I say SQL all, what it ends up doing is it ends up dumping the SQL for that app for me, right? This is what it would use if I were to sync this up to the database. And you'll notice, to answer that question I got asked a second ago, integer not null primary key, right? So it created that ID field on its own. right? If I wanted to have an alternate primary key or something else that I created as a primary key, all I would have to do is say primary underscore key equals true, and that would set it up as a primary key. Django also supports in what we call class meta things like composite primary keys, right? So I can have a primary key that's based on two fields, or I can do things like unique togethers where I have two different fields that have to be unique, or commonly alternate primary keys, unique together, not nulls, stuff like that. It's all supported using the ORM language. In this case, we're going to stick with the basics, right? So what I've got here is I've got the SQL that it would use to create this thing. You'll notice that just like I said, hello underscore world underscore event, right, is what it used as the name. So app name underscore model name, that's going to prevent name collisions. There are ways that I can manually specify what I want the model name to be. The other thing that's possible that Django can do is it can reverse engineer an existing model, right, or an existing database. So the idea is I can point it to a database that somebody wrote a long time ago using some other language or some other framework that I think doesn't work very well, and I can say, hey, Django, reverse engineer this particular model for me. And it'll build the model for me using the database. Now, typically when you reverse engineer like that, there's a little bit of work that's involved after the fact to sort of make sure that everything looks the way you want it to. Django's only so smart, but it's really nice if you have, for example, a 16,000 table database, as I recently encountered, and you want to reverse engineer it and you want to use it for something. I didn't create that 16,000 table database, just for the record, but there was one. So the idea is that Django has lots of cool reverse engineering tools and techniques that we can leverage as well to get this sort of thing done. Questions about this? All right. Obviously, I don't need to connect to my VPN. All right. Yeah, that's fine. Okay. So where were we here? All right, so we define the model. The ID column is automatically added unless we create our own primary key. The parameters that we commonly pass in when we're creating these things, so we have things like relationships, foreign key, many-to-many key, many-to-many field, one-to-one field, generic foreign keys, stuff like that. Arguments that we can pass in, db underscore index equals true. If we pass in db underscore index equals true, when the model gets generated, it'll go ahead and index that field. If we go back over to my example right here, and I say, db underscore index equals true, and I take a look at that SQL again, right, you'll notice that now there's a create index statement down here, right? So it goes ahead and it creates an index for me as well. So the idea is that it can handle all this stuff, right? There should never be really a reason for me to go into my database and do things like create index statements and so on and so forth. Django's ORM can handle a lot of that for me, right? Now, generally speaking, once Django pushes a model into a database, I can't make changes to the model anymore, right? In the sense that if Django looks and sees the model's already there, it's not going to go and figure out what the alter table statement is and whatnot to upgrade the model to my own thing. I can use SQL all to see what the SQL would be, and then I could write my own little SQL script to apply the alter table change. Or I can use one of these Django migration tools like South, right? Another add-on for Django that allows me to handle lots of cool database migration type stuff, right? So South can take care of a lot of that work for me, once again using tools and techniques like the Django ORM. All right. Table naming conventions. I already talked about the naming convention. App underscore class name. It's going to go ahead and it's going to convert the name of the class to lowercase, because we all know that mixed case table names are a bad idea in general, right? If you camel case the name, it'll convert it to lowercase, and where there's a case change, it'll go ahead and put an underscore in, right? So for example, if I just call this thing event stuff, right? And I were to then run the same command, you'll notice it calls it hello underscore world underscore event. Oh, stuff. Okay, it puts it together. But in this case, you'll notice that it folded all to lowercase, right? So the folding all to lowercase is important. Different databases handle case differently, and generally speaking, bad idea to use mixed case table names. So, okay. All right, so there's an example on page 46 here that kind of shows you how we create a model for Django. Let me ask you a question. Is there supposed to be a break in the middle, or we just go straight through? Does anyone know? All right. Cool. We go straight through. That's fine. Works for me. I just didn't want to deprive you guys of a break if you were expecting one. So, okay. So sample code here. Here's our event one, right? You'll notice that in here there's some help text. The help text is things that can get leveraged later when you start converting these things into what we call model forms. One of the neat things about Django is because our models are defined using Django's ORM, and forms have their own Django components, what Django can automatically do is take a model and convert it into a form for us, right? And it can validate it, and it can save it and convert it back into a model for us. So just by creating the model, right, we almost automatically get the form for free, and we almost automatically get validation for free as well, right? I say almost because a lot of times we have our own complex validation that needs to be applied, but generally speaking, Django gives it all to us for free, right? So here's a sample, right? So in this case, we've got some fields here that make up our events model. We have some fields here that make up our people model. And then if we do an SQL all, you'll notice that what we end up seeing is the information along with the relationships. In a many-to-many field environment, right, or in a situation where we're using many-to-many fields, you'll notice that down there it actually creates an intermediary table to represent that many-to-many field. So Django takes care of all that work for us. And what I'm going to do is I'm going to make my model a little bit more complex. I'm actually going to make an enrollments. And I'm going to say, no, I'm going to make a people. Well, what did I do over here? Did I do enrollments or people? Yeah, I did people. I'm going to go ahead and say first equals models.carfield max length equals 64. Null equals false. Last equals models.carfield max length equals, and you guys can follow along if you like, null equals false. And I'm going to say event models dot many to many field max length equal models dot many field, and in this case event is the model that we're referencing, right? Now, one of the things that people sometimes make a mistake at doing when they're early on is, we have this whole concept of hierarchy. Obviously, I can't reference event over here unless event's already been defined, right? So Python is going to end up reading down this file, right? If I want to, though, I can use what we would call lazy references, right? So instead of actually saying event, I could just put the string event in here, and then the order doesn't really matter, right? If I define one before the other, who cares? Django's not all that concerned because it's going to do it lazily, not until it actually starts to. I'm going to go ahead and do my SQL all again. Let me save my model first here, and then we'll do the SQL all, and we'll take a look at what it looks like. Hey, there we go. So we've got our event table, we've got our people event table, and we've got hello world people. Now, that's nice and all. I've created this thing. I put some data inside of it. Now what I want to end up doing is I want to end up pushing this into my database, right? And that's done using a command called syncdb. What syncdb is going to do is it's going to go and it's going to push my model into the database. Now, it turns out that the auth model or the auth app is already included here. So because the auth app is already included, the auth app has its own models, things like users, groups, permissions, and so on and so forth. That gets pushed in there. It looks like we've got some stuff in there to handle session managing and multi-site configuration, content type information, stuff like that. That gets pushed in there as well. You'll notice those are Django underscore ones. Basically, they're included by Django, right? They're Django components. And then finally, there's my 3 models that I said I wanted to create before. Now, I mentioned earlier that Django does have an administrative interface. In order to log into the administrative interface, you need to be a super user. But by default, obviously, my database isn't going to have any users inside of it. So when I actually go ahead and install this model, what it's going to end up doing is it's going to end up saying, hey, do you want to create a super user? And of course, I'm going to say no, because I don't really care about that right now. Great. Now this information's actually been created. It's inside the database. Let's talk a little bit about how we can query and access the information first outside of views, and then maybe we'll talk about them inside of views. Great. Oh, I skipped the validation step. Well, I did an SQL all. That validated most of my model. There is a validation step that allows me to make sure that my model looks valid. It looks okay. Generating and running the SQL is what we just did. So SQL all allows me to say, all right, run all this stuff and push it up into the database. Bam, we're there. Adding data to the model. Now here's the fun stuff. So what I'm going to do is, rather than doing this inside of a little bit of Python code, I'm going to leverage my, my shell that I showed you guys earlier. I'm going to say python manage.py shell. Now in this case, that model is actually stored inside of hello world models. So what I'm going to do is I'm going to say from hello_world import models, right? And so now what I have is I have my models module that's been loaded here. And now what I want to do is I want to create a new instance of a event, right? So I'm going to go ahead and say e equals models.event. Now the way I create a new instance is really, really simple. I use keyword or key value pairs, right, as named arguments into this thing. So inside of my event, we've got start date, end date, and name. Oh, before I do that, I have to say import. What's it from date time? Import time? No. Import date time dot date time. That today. Date time always messes me up. Yeah, there we go. So there's a date time object, right? We'll just make the start and the end date today in any case. So what I'm going to do is I'm going to go ahead and say today equals what is it? Date time dot time delta. Ooh. Great. So let's see. Yeah. Great. So what I'm going to do is I'm going to go ahead and I'm going to say my start is date time today. And I'm going to say my end is 2 days from now. So there's a long event. And maybe that's, well, it's not PyCon. And now I'm going to create the new object. So I'm going to say models.event. And I'm going to have start equals start. I'm going to have end equals end, and the last element in there was end. Oh, that's end date, and start date and end date. Okay, and then name. I don't know if I can modify this. Nope. Okay, let's try that again. Start date equals start. I'm going to say end date equals end, and I'm going to say name equals PyCon 2012 tutorials. Great, and you'll notice that what I end up having or getting back here is an event object. I want to, oh man. All right, I want to save it. So I'm going to say e equals man, I'm not betting 1,000 today, am I? Okay, start date. No, end date's here somewhere. End date. Name, there we go. Great, so now I have this event object, right? But if I try and look at the primary key, you'll notice I get nothing back. The reason is just because I've created the object doesn't mean I've actually persisted it into the database, right? What I've done here is I've created an instance of the object, and the assumption is that I may make lots of modifications. In fact, I may not even have provided one of the required arguments when I actually created the instance. That might be coming a little bit later. I can look at all the other things, though. Start date is there. It's a date time object, right? The name is there. And if I wanted to save this into the database, I could use the save method. Now, once I've saved it in the database, now what I end up having is that primary key field is defined. Or a shortcut that I always like to use for primary key is just .pk, right? Nice thing about .pk is that if you reverse engineer somebody else's model and it has a bunch of primary keys that are non-standard names, well, you're going to go ahead and find them with pk in that case. So in this case, pk is shortcut to id. So the idea here is what I've done is I've created an instance of the object, just like I would do with normal Python, right? If I want to work with an object, I'd create an instance of it. That object has a save method that I can use to save the information in the database. How would I get rid of it? Right, the object has a delete method as well. I'll show you that the delete method is there, but I'm not going to actually run it. See, the delete method is there. But I'm not actually going to run it because I don't want to remove that information from the database. So the idea is I can go ahead and I can save stuff into the database. If I wanted to change it again, it's not going to get saved immediately. I've got to call the save method. So over here, if I decide I want to change the name, I can save it. I can see it there, right? But it's not actually saved, right? I would have to call the save method to actually save it into the database, right? I can see that if I do this. Oops, model. Right? I can see the information that's currently in the database. We'll talk about querying in a little bit. I just ran a query against my data model, right? I can see what's in there right now. Obviously, that changes from what I have right now, right? What I have in my object right now. But of course, if I call save, that's going to persist it. Now, here's the question. Can anyone tell me how Django knows to do an update versus to do an insert in this case? The primary key is defined. Right. If Django has an instance of a model where the primary key is defined, it's going to say, okay, well, you know what? The primary key is already defined. I'm going to go ahead and I'm going to do an update. If it's not defined, it's going to go ahead and do a delete. Or, sorry, not a delete. It's going to go ahead and do an insert, right? That would be really funny. So it's going to go ahead and do an insert for me. So the idea is once we've got these objects, we can start creating things. Let me go ahead and create one more. I have an event object already. It's saved inside of E. So I'm going to go ahead and create a people object. Here's people. So I'm going to go ahead and say p equals models.people. And we have first, last, and event. First equals me. Last equals me. Event equals E. Is that right? What did I call it here? Oh, right. So I'm going to go ahead and do a p.save. No, I'm going to say what do we got there? There's something wrong. It's event dot. We'll get to it in a little bit. My brain is not working here. Let's just take a look here. Oh, right. Got to save my people object. And then I've got to assign the events, right? And of course, it's a many-to-many relationship, so that that event is a list of events. It's not just a single event, right? But obviously, I can't put something in the intermediary table unless I've saved the original person object, right? So the first thing I do is I create the person object, I save it, and then I go ahead and I assign the events for that person object. And then as a list, right, of events, because it's a many-to-many relationship, and then I'm going to go ahead and save it. If it was a foreign key relationship, like it'd be a lot easier for me because one person would just map over to one. And because I would have the primary key for the event already, it would be easy for me to point things, right? You still have to think in terms of the database here, right? If we're assigning a relationship between two different objects, obviously there needs to at least be a primary key that's already been defined for one. Django isn't going to do a cascade save for you when you try and assign one thing to another. It's going to assume that it's already got a primary key, and it's going to go ahead and assign the primary key value, right? Questions about that? No. Oh. We'll take what do you guys think about a 5-minute break? All right, let's take 5, and we'll go from there. Hopefully, everyone's back. If not, hopefully you'll be back soon. All right, so simple data retrieval. So we already, I didn't talk about this. Great. So I got some information that is inside of this model, right? So I built this model. I got some stuff in people. I got one thing in event. And now what I want to do is I want to query it. Now the first thing you need to understand about Django is that when we're using the Django RM, we're going to use a lot this concept of a thing called a query set object. Now, a query set object we get using a model. Right? And you'll notice that models.event.objects.all. You'll notice that when I call models.event.objects.all, what I'm actually getting back is I'm getting back this thing called a query set. I'm going to say QS equals, and I'm going to go ahead and I'm going to say type of QS. And you'll notice that it's actually a Django DB models query set. Now, query sets are kind of interesting things. What they are is they're essentially the holder for a query. The idea is that in Django, what we end up doing is we end up creating these query sets. And these query sets are lazy objects. Basically, when I try and retrieve information from a query set, the query set will go against the database and it will run the query to retrieve the data. That's why over here, when I just said models.events.objects.all, it actually returned to me a list of stuff. But this thing is actually not a list of stuff. You'll notice the type is not list, right? The reason the type is not list is because I've gotten back a query set object. And it's not until I try and look at the data that it goes to the database to try and run the query. Does that make sense to everyone? That means that if I, for example, create a query set object and I put it into a template, and I expect the template to iterate over the results to generate a table, but the template never goes to do that, the query never gets run. So Django is smart enough so that even if you create some query sets, if you don't use them, if you don't try and retrieve the data from them, the query never ends up getting run. Right? Now, if I actually take a look at this query set, let's see if I can remember what the attribute is. You'll notice that the query itself looks something like an SQL query, right? Internally, you know, I'm actually taking a special, this isn't something you would normally look at, right? But what this ends up doing is it ends up showing me something that looks kind of like an SQL query that will be run against this particular model. In this case, it's select all. There's no ifs, ends, wheres, and buts about. I mean, there's no other query predicates, right? And when I actually try and use the query set, for example, as a list, what it ends up doing is it ends up giving me or running the query, returning the results, and then once it's returned the results, I'm looking at that list of results. I'm actually looking at the name for the first row that came back from the query that I just ran, right? So as soon as I try and start evaluating it in a list context, right, Django's going to run the query, it's going to return to me the results. That query set is always going to return to me a list of values, right? So when I evaluate a query set like this, I'm going to go ahead and get a list of values, and that list of values I can then use in any iterative context, right, to return the results of that particular query. Questions about this? Until I try to use it, right? Until I try to retrieve the results in some way, it's not going to end up running that particular query. It's a lazy, query sets are lazy by definition, kind of like me. Okay, so I've got this query set. Obviously, you'll notice that before, well, let me go ahead and put this back the way it was before. This query set. Now this query set, you'll notice says events.objects.all, right? But it turns out that query sets have a couple of other methods that we can use. The most common one that we'll talk about is the filter method. Now, every single time I have a query set, what I can start doing is I can start applying different filters to that query set. And every single time I try to apply a filter to a query set, what it's going to end up doing is it's going to end up returning to me an entirely new query set. You can almost think of query sets as operating kind of like the immutability of a string in the sense that anytime you run one of these methods against a string, you get a new string back. Anytime you run a filter against a query set, you're going to get an entirely new query set back that represents that new query. So for example, here's my query set, right? QS2 equals dot filter. And in this case, what I want to do is I want to go ahead and find where name equals PyCon, right? And if I actually go ahead and say, if I do my little tricky thing right here, and I look at that, you'll notice that now what it's ending up doing is every single time I do one of these, right, it's going to end up altering that query somewhat internally. Now, obviously, the representation that it's using, it's not this string representation. It just turns out that if I look at this query object, right, qs2.query, I'm going to end up, as a string, it's going to end up giving me something that looks kind of like SQL. What it actually is it's a query object. And that query object, at this point in time, could run against any one of the databases that my ORM supports. So it's actually not translated into like the real SQL query until it comes time to run the query, right? Or until I tell it to give me something that looks like a query. So the idea is I have these query sets. I can apply filters to these query sets. Every single time I apply a filter to a query set, I get a brand new query set back. And I can stack these filters, right? So I could say .filter, 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 and I can apply all kinds of different filters against the data that's coming back or that's being pushed into this database query. And it's only at the very end when I actually try and retrieve the results that it's going to go out and it's going to run the query to return the results to me. Does that make sense to everyone? Okay. That's more or less it when it comes to query sets. Anytime we try to slice, iterate, pickle, or cache a query set, do a repr length list, anything that's going to end up evaluating it, that query set is going to basically have the database or Django run the query and return the result to me, right? So it's running the query, it's returning the result to me. Another important thing here is pickling, right? So if I pickle it, I'm not actually pickling the query itself that I've created the filter for. What I'm actually doing is pickling the results of running that particular query. So important distinction there, right? The idea here is we want to go ahead and wait until the last possible minute to execute that particular query. The hope is that, we're going to find those programmers that, build lots of query sets but never use them, right? And we're going to eliminate a lot of the inefficiencies that come from bombarding the database with all of these queries that, really are never going to end up being used, right? The results of which are never going to end up being used. And it allows me to take a query set and slice and dice it multiple ways, right? So I can apply this one filter on this query set, and then I can apply a different filter and have two different query sets that I can work with two different query results, right? So filters. So the way we use filters is we use the filter method, right? The filter method is an inclusive method, right? So that's like saying the value has to be in this particular thing, right? And then inside a filter, we're going to use something that we refer to as a field lookup, right? And the field lookup is essentially some sort of Django syntax thing that says, hey, look for the value that matches such and such, right? The value that matches this thing, right? Now those field lookups are a little bit more complex than what I showed you a minute ago. Here I said name equals PyCon. This is what we would call an exact field lookup. That means that name has to match PyCon in a case-sensitive manner, right? I think that the MySQL may not do the case sensitivity. I don't know. I don't use MySQL. But if I want to, what I can do is I can take a field name and I can use the double underscore, and I can use sort of this modifier thing, right? So in this case, iContains, for example, right? iContains says case insensitive contains query, right? And if I look at the query again, you'll notice that now it's actually converted into a like query, right? Like %PyCon. Chances are that SQLite is probably case insensitive to begin with, or something. So, and that's why the query actually doesn't say like I like or anything like that. But depending on the database that you're using, you might find the query that you get ends up looking a little bit different, right? So this is iContains. I could do PK __ in, right? And then I could go ahead and say 1, 2, 3, 4, 3, 4, 5, right? I give it a list of values, right? And if I look at the query that would be generated from that, you'll notice it's going to be an in query, right? That double underscore is pretty important here, right? The double underscore says basically, now we've got this modifier, right? And that modifier is essentially going to allow us to do different types of queries. It's also the way we follow relationships, right? So for example, in this case, we are looking at event, right? So we're working with events, event objects in this case. And what I want to do is I want to go ahead and say people _ set oops, people underscore PK equals 1. So in this case, what it's doing, right, is it's actually doing a join with the people table, right, to find all those events where there's a person that has the primary key of 1. Right? Or what I could do is I could say person people underscore name underscore I contains A, right? Oh, it's not name, it's, I guess I called it first and last. So I'll say first contains I contains A, right? So the other thing that we use these double underscores for is to follow these relationships. Right? So it's really easy using the syntax, right, for us to leverage these relationships that are defined between our different models. Right? And you'll notice that, I'm doing something really simple here. Django's building the appropriate query behind the scenes to find all those event objects where there's a person inside the event or person enrolled or attending the event whose name contains the letter A. Questions about this? No? Yes. This isn't the actual SQL. It's something that kind of looks like SQL, but may not be necessarily executable SQL.
Right. And so the nature of my question is, depending on the database that you use,
Correct. Yes. It's going to create the SQL that's specific to the database. It's based on, well, Django has support for different, inside of your database engine, or inside of your settings.py, when you define that engine, you defined the database that you were using. You also defined the ORM component specific to that database. So everything that's going to be used to build those queries and execute those queries and retrieve and manage results that come back, all that stuff, right? In some cases, it's even possible if the database doesn't support something for it to be done internal to the ORM. So maybe it retrieves more data, but then it can still do regular expression evaluation or something like that, right? So it's possible. I don't know how often that's done, but that sort of thing is possible as well. And adding support for another database is just another is just the point of building the driver that would support that backend database using Django. Other questions? Nope. All right, so the idea is that we can build these query sets. Remember, the queries haven't been executed yet. It's a matter of actually running the query at the end, right? And running the query at the end is actually starting to look at the data that comes back, right? So now if I go ahead and I say for row in QS2, print row.pk, right? You'll notice that it's going to iterate over all the events that I've got. Right now I only have one event, one person that's enrolled. But I do have a person whose first name contains the letter A, my name, right? So it's going to end up going ahead and retrieving that information, printing out the primary key for that particular event. Now, if we had another child table to the people table, we could exploit that relationship using that same double underscore technique, right? So we could say underscore, underscore, and then we could reference the child, right? And we could say underscore, underscore, and we could reference the child. So Django is going to follow those relationships for me wherever I've defined those foreign key relationships. And it's going to take care of building the SQL that'll exploit those for me. Yeah. Well, you can either comma separate them in one filter call, right? Or I could take this query set that's being generated as a result of doing this, and I could say QS3 equals QS2, and I could apply another filter to QS2, right? Or what I could do is I could say QS2 equals QS.filter.filter.filter.filter, and I could apply different filters there. Or I could do things like filter.exclude, right? The difference between the filter that I'm using here and exclude is going to essentially say not in, or not contains, or not equals, or not whatever, not like, right? So it's going to use the opposite of that. So filters include this constraint. The exclude is an exclude constraint, right? That says don't include these particular values as well, either, right? So the idea is that we build these things the way that we want to build them, right? Get. Now get is actually, the expectation with get is I pass in a filter into get, right? Or I pass in my query criteria into get, but the expectation is I'm doing something along the lines of a primary key lookup. I'm going to only get one result back. I'm not going to get a query set back when I do a get. Instead, I'm going to get a single object that represents the results. If I don't get an object back, so that get doesn't match anything, it raises an exception. If that get matches more than one record, it's going to raise an exception as well. So get's like me saying, I'm doing a primary key lookup, I just want the one record. Don't give me anything else, and don't give me anything less. Questions about get? Great. And all right, so here's another example of a model, right? We have events, we have schedule, we have people. You'll notice there's relationships here, enrollments, many-to-many, nothing there with schedule. Schedule's got to be related somewhere. All right, schedule's not related anywhere. It's just a model by itself. So the idea here is that we can use these field lookups. I talked about the double underscores, right? So the idea is I can use that double underscore. For that reason, one of the things you should keep in mind is that when you define your models, don't make fields that contain double underscores, right? Fields and models can't contain double underscores. Fields and models can't end with a single underscore, right? Generally, you don't want a field in the model to start with an underscore either, because that's equally confusing, right? You can almost think of Django taking those keyword arguments and splitting them by the double underscores. And so if it tries to split by a double underscore and there's a triple underscore there, you're going to end up with something that's funkified, right? How it's funkified, I'm not sure, but it's going to be kind of funky. And you'll get an error back, right? So try to use, you can use underscores inside, but don't use them in the beginning, don't use them in the end, and any of the fields you define in the model, right? If you're taking an existing database and that database field ends with a double underscore, that's okay. Inside of the model, you have the ability for each of the fields to specify the underlying database field name. And if you use Django's reverse engineering components, Django will show you that on its own, right? So it'll show you, oh, look, my model name is such and such underscore one, or underscore one. And then it'll say db field equals, and it'll show you what the name of the field is. So the model names, the names for the attributes of the model don't need to match the column names in the database. That's not a requirement. Though generally it's done, right? And then finally, if you do an equals, that's like an exact match, right? So an equals, I showed you that already, it's an exact match, has to match exactly. You should assume that it's going to be a case-sensitive match, right, for the most part. Okay, so here's some examples, right? Exact, that's an exact match. Well, you know, these two are exactly the same. Turns out if it's a date field, Django is going to take that data that you give it, it's going to coerce it in the appropriate format, and then it's going to run the right query. It's got to look like a date, or it can be a date time object or a date object if you're doing those sorts of date matching. iExact is a case-insensitive exact match, right? So case-insensitive exact match. Contains is like an SQL-like. We've got in, where we can specify a list of values, right? Great. So we have in, which allows me to specify a list of values. This second one, don't pay attention to this. This actually generates what we would call a subquery expression that we add in. We're not going to go into that in too much depth here. And then it passes that query set in the in clause. Well, actually, maybe this is something that's worth talking about. I was showing you that query attribute, right, which was that sort of that query object that you saw. One of the things that I can do is I can generate query sets. And then once I've generated query sets, I can actually use those inside things like in, which is kind of like building a subquery in Django, right? So we've got this query thing, and then I'm going to add that query thing into my current, into a query set, and then that becomes a subquery in Django. So greater than, less than or equal to, greater than or equal to, starts with, ends with, range, has to be within a range of values. So you give it a two-tuple that contains the start and the end. Year, year is kind of neat for a date time field or whatever. It'll do the year lookup, right? So it'll look for something or values that are within that particular year. You can also do month, and you can also do day. Obviously, for most databases, doing like a month-day lookup on a date time field is going to be a relatively inefficient thing to do, but Django supports that, so it'll build the extract month from year, or extract month from date, equals, and then it'll give it the value. Is null. Search utilizes a Boolean full text search mechanism, so kind of cool. It can do full text searching type things. And then it has support for regular expressions, right? So you can do regular expressions, case-insensitive regular expression matching inside of it. Now, one of the cool things about query sets is not only are they lazy, but you can slice them and dice them. Once again, we go back to our Ginsu knife comparison, right? You can slice them and dice them. The idea is this. If I have a query set, and I say :10, for example, right? What ends up happening, right, is it ends up, rather than actually running the query, so even though it looks like I'm evaluating it or whatever, rather than actually running the query, what it does is it gives me a limit, right? So it applies a limit to that thing. I'm not actually looking at the data yet, I'm slicing it. And when I take slices, Django's going to apply the appropriate limit statements, right? If I go ahead and I say 1 to 10, you'll notice that what it's going to end up doing is it's going to limit 9 offset 1. Right? So it's going to build the appropriate expression to represent that slice. Once again, it's not running the query, doesn't need to run the query until the very end. So I can slice these things. And there's some examples over here, right, where we apply filters and then we do different slices, right? So this one skips the first 20 records, this one says give me a limit of 20, and this one says, skip the first 9 and give me 10 or something like that. Ordering. When we build query sets, we have order by methods that we can use. So order by methods allow me to basically say order by this particular column, right? So here I'm saying order by the start date, and then the secondary order by column is going to be the start time, right? So I'm going to get these chronologically ordered by their start timestamp. Make sense? Other methods that we commonly use. Reverse. Reverses the order. So you do an order by, then you do a reverse, and then what it's going to do is it's going to do an order by, and then instead of ascending, it's going to do descending, right? So it's basically just going to add the DESC keyword or the ASC keyword. Distinct. Distinct allows me to select duplicates, right? And I can give it a list of fields that are going to be considered to be part of that group. None gives me an empty query set. So for various reasons, we may want to work with empty query sets at different times. So none gives me an empty query set. Select related. Select related is kind of cool when we have a query set. One of the things that the query set's normally going to do, does anyone here use Hibernate? Yeah. Okay, so one of the things that you commonly find with different ORMs, things like Hibernate, right, it's a big complaint a lot of times among Hibernate people, is that it won't expand those relationships unless you very explicitly tell it to. The way Django works is we can say select related, and we can either give it a list of relationships that we want it to join to return all the data, or we can say depth equals and say go this far deep, right? Now the cool thing about this is that query sets are lazy by definition. If I retrieve information from just one table, and then I want to follow the relationship, when I follow the relationship, it will run the query to retrieve the data. So if I grab everything from events, and I don't say also give me the people data, when I end up going to event.people, it's going to go and it's going to follow that relationship, run the query, to give me the people associated with that event. If I give it a depth argument, it will automatically build that as part of the base query. And it will build those child objects as well. That way, when I'm trying to access the information, I'm not running a bunch of small secondary queries to retrieve related data. I use one query that retrieves everything, the parent and the child table or tables, and all I have to do is access the information directly, right? If I don't do that, then what I end up finding is I can beat my database to death with lots and lots of small queries as I retrieve my 50,000 events, and then I try and go and retrieve all the people for all those 50,000 events. I'd much rather run one huge query that returns to me a huge result set than run one small query where I have to run 50,000 additional queries in order to return my result. Does that make sense to everyone? That's what select related allows me to do. Extra allows me to actually provide some manually generated SQL. Obviously, that's something that we don't like to do unless we have to. And then finally, count actually runs the query, but instead of returning the results, it just returns a row count to me, right? So the idea behind returning a row count in this case is then I can, I can say, oh, there are X records that match your query, and then I've got the query set, do you want to run it for real or whatever, and then I can go off and run that query. Obviously, if I retrieve the records and then count through them, then I'm doing the work of retrieving all the data, and then I'm iterating over that object to count it, right? Not so great. If I can do a count, the database does all the work for me. And obviously, if the database can do the work, hey, that's where it should be done. Deleting records. The way deleting records works is we can either take a query set and we can use this delete method, which will delete all the records, Or what we can do is we can go ahead and we can take a single object and we can use the delete method on it. We already talked about the delete method on a single object. The delete method on a query set works very similarly, right? In the sense that I can delete everything in the query set, right? So here I have a query set, I do a filter, and then I go ahead and delete those records that match that particular filter. Questions about deleting? Deletings by default will generally cascade, right? But when we define these relationships, I think with Django 1.3, I don't think you could do it with Django 1.2. With Django 1.3, you can specify whether or not you want to do delete restrict versus delete cascade. Obviously, if you do a delete cascade and you delete one event, you're going to delete all the people records associated with that event potentially, right? If you have a foreign key, right? On the other hand, if you do a delete, I think the option is there to restrict, and I think the option is there to set null as well. I'd have to look to be certain of that, but restrict is definitely in there, right? So we could say, oh, when you delete this event, well, you can't delete the event because there's 50,000 people that are registered in it, right? Which would maybe be a big thing. Managing related records. So we've kind of talked a little bit about this, right? When we define the model, we define the relationship. We talked about how if it's a many-to-many, what we need to do is we need to pass in a list of all of the child records that need to be related to this one parent record. The same thing is true if we have a foreign key. When we create a record that is a child in the child table, we have to pass in the parent table, right, so that that link is established, right? So some examples over here. Here we create a person record, we save that person record, and then what we end up doing is we end up saying, all right, I want to go ahead and create an address record for this person record, right? In this case, I could have done two things. I could have said, created an address record and say person equals whatever. Or what I can do is I can just go ahead and follow my current people record, right? And I can create the child record. Now, generally speaking, when we define relationships between two models, the example is not really clear when I did it over here, but when we define relationships between two different models, come on, computer. There we go. Okay, when we define relationships within two different models, rather than saying many-to-many field, I'm going to go ahead and say foreign key. When we define foreign key, if I'm in the people object, I can use event, right, to reference all events that person, or the event that person's related to, right? But if I want to get from event to people, what I'm going to end up using is I'm going to use people_set, right? So Django automatically defines the forward relationship as something _set, and it automatically defines we've defined the reverse relationship as event. So if I look at people.event, I'm going to find the event that person's related to. If I look at event.people_set, I'm going to find all of the people that are registered in that particular event, right? Now, in the case of the many-to-many field, this people has an event attribute, obviously, that would give me the list of events that the person's enrolled in. And the event object would have a people attribute that would point to a list of the people that were enrolled in that particular event. So in that case, we don't see the __set in the many-to-many case. We see it in the many-to-one case. And we can actually see that. Did I save this? No, I didn't. Good. So if I go back over here, I think we already did an example like that, right? But if I look at models.event.objects.get pk equals 1, lowercase o in objects, right? And I look at people here of that, people_set. I misspoke. It is _set. In both cases, right? People_set. That gives me the manager for the people object, right? So now if I wanted to get all the records, I could use .all to get all the records, right? So people_set is going to give the manager for the people object event. Once again, it works in both directions, right? So the idea here is that I can follow those relationships. Now it turns out that every single time I have a manager, the manager has an attribute called create, right? So that model manager has an attribute called create that I can use to create a new instance of that particular model. I could do that as well just by creating an instance of the model, right? The nice thing about the manager in this case is the relationship is already there with the address table, so I don't need to worry about having to specify what the primary key relationship is in this case. Django's going to take care of all that work for me. Questions about this? Nope. And here it is going the opposite way. Right? Oh no, this is the same thing. I have enrollments and people again. Right? So I'm creating a new person that goes with an enrollment. All right, retrieving related records. So this is pretty simple. I've already talked about all this, right? So the idea is that I can use a field, and I can use all those different methods that we talked about. Or what I can do is if I get a particular record, I can follow the relationship to retrieve all of the related records. So just like we had people underscore set before that I showed you, right? That's a query manager, that's a query set object, but that query set object already filters so that the primary key matches that relationship that we already talked about, right? So as soon as I have one element and I look at the query set, well, that query set is going to contain, I don't know if it'll show me that, right? So people set dot all. Yeah, you'll notice that it's already contained. So it's giving me a query set back, and that query set already contains the relationship over to that event object. You guys see that? So the query set already contains that relationship. So what Django's doing is it's building essentially a default query set for you, and that default query set already has the relationship there. So you're only going to get those related records. And of course, query sets, once again, all the same techniques that we learned about before are there. So if I wanted to find all the people or all the events with people, and then if I wanted to find people with a certain name or with a certain phone number, certain zip code or something like that, I could go ahead and I could use this same mechanism to find all those related elements. Right? And we talked about select related. Basically, it goes out and exploits those relationships from step one, so that way we don't have to run lots of small queries. Once again, I showed you how we could actually go through and follow these relationships with those double underscores. You know, the double underscores are essentially our relationship follower, right? Every single time I add the double underscore, I'm following a relationship. And finally, the last thing after a double underscore is going to be the match criteria, right? So if it ends in double underscore, it's going to be a match criteria. Exact, contains, in. So one of those match criterias, right? Of course, if there's nothing, then it's going to always be an exact. And in fact, leaving off the underscore exact here is the same as actually putting the equal sign in there. They do the same thing. Q objects. All right. Now, one of the things that we commonly find, or we sometimes find, is that when we're running these queries against the Django ORM, sometimes there's some complex criteria that we can't meet. The biggest one is OR criteria, right? I don't know how many of you have noticed already, but we didn't have a way to apply an OR. If this is true or this is true, right, I could do an in, but what if I wanted to do an in with like a like, right? So in is my closest analogous tool to do an OR. What if I wanted to say where first name is like this, or last name is like this, or zip code is this, or area code is this, right? Well, in that case, Django's query sets kind of fail me, right? And they fail me because they don't really provide me with an OR mechanism. That's where Q objects come in. One of the things that Q objects allow me to do is they allow me to specify generic query criteria. You'll notice that over here it says ID underscore less than or equal to 3. There's a vertical bar here which basically ORs this with that second criteria, ID underscore greater than or equal to 14. Now you'll notice in this case this isn't tied to a particular object, right, until I pass it into a query set. And as soon as I make it a filter for a query set, now what it's going to end up doing is it's going to end up saying events objects ID less than or equal to 3, events ID less than or equal to 3, or events ID greater than or equal to 14. I could also go so far as to say Q people underscore ID greater than or equal to 13. And when I pass that into events, it would then exploit the people relationship, or in my case, people underscore set, right? And it can follow that relationship as well, right? So the idea is the Q object is something that I would pass into a query set for something like this, but instead of me having to pass them in an additive fashion, I can AND these query sets together, I can OR these query sets together, and so I can produce very complex OR and AND criteria. Does that make sense to everyone? Right? Yeah. Right. Well, it doesn't know which ID to point to. Here it's almost like it's building a generic component to a where clause. ID equals this, ID greater than or equal to that. It knows once it passes it into the query set, right? So here we have a query set for the events object. So now it becomes events.id, events.id. Well, so you would always have to make sure you build your Q objects using fields that are defined in the model that you're querying. Does that make sense? So when I build that Q object, I need to know what fields exist in the events model. And when I build that Q object, I'm going to use the fields that are in the events model because I plan to pass it into a query set that's built from the events model. Yeah, I don't know if it does it immediately or if it does it when it actually executes the query, but in the end, what you're going to find is the query is going to fail to run because the field doesn't exist. So I've never done it with a field that's not there, so I don't know whether it does it immediately or it does it after the fact. I'd have to try it and see. Yeah?
But if you had a couple of different models and you happen to have field names in common, you could construct a Q object using one of those common field names and then apply it to either.
Sure. Yep. Most definitely. So the question was, is that if I have a Q object and I'm using, we'll use ID or state as an example, and I have an events model that has a state where the event's being run, and then I have a people model that has a state where the person lives, I could take that same Q object and I could pass it in as a filter to the events object, and I could pass it in as a filter to the states. These Q objects, and this is the key, right, they're not tied to any query set, right? They're generic standalone objects that provide me with very, very basic query criteria. They get tied to a query set when I pass them into the filter, right? Or the exclude, right? I could just as easily say qs.exclude and pass in this Q object, right? And I can and or as many of these together as I want. So if I'm building a very complex criteria where the ID is this and not this or whatever, right? I could start using these query sets in sort of an and or additive type fashion to build more complex Q objects. And then I could pass those in, right? Generally, this is the way we do things like or type queries. All right, questions about queries in general, the Django query mechanism. Sessions and users. I want to see if we're doing, all right, cool. Questions? All right, I want to talk about a couple of topics really quick, and I'm hoping that we'll have a little bit of time to talk about model form before we wrap things up. But what I want to do is like right around 12:10, I want to wrap things up and open up some time for Q&A if there's Q&A. But we've got a bunch of stuff to cover before then. So we'll see where we get. The slides don't actually contain model form, so not such a big deal. All right, the admin interface. Now, one of the cool things and one of the reasons people love Django is because Django has an administrative interface. The whole idea behind the administrative interface is that because I've defined all of these models, and I've defined these models using Django's modeling framework, Django understands what these models look like. It understands how to build queries to query these models. It understands how to put data inside of these models, which means that Django can provide me with some automatic mechanisms to handle a lot of this stuff. Now, the way we generally do this is using Django's built-in administrative interface, which is like the best thing since sliced cheese. The first thing I need to do before I can start using the admin interface is I'm going to need to create a super user for myself. So I'm going to go ahead and I'm going to say, Python manage.py. Is it create super user? I could use help. I could type correctly. Hey, there we go. Create super user. And so I'm going to go ahead and create a super user. I'm going to go ahead and use a Chunder. Oh, let's try that again. My first name. My password is going to be Chunder. That way I won't forget it, or at least someone else will remember it. So I went ahead and I created a super user. Right now, this is going to create a new user inside of the Django, auth tables, right? That I can actually end up using to manage this thing. And I'm going to go back to start my my admin server again. If I can find that line, there we go. Now we want to enable the administrative interface. Now the first thing I need to do to enable the administrative interface is I need to go into my app level urls.py. That's not it. There we go, my app level urls.py. And all I need to do is uncomment a couple of lines here. I don't care about the admin docs. So I'm going to uncomment a few lines here. Right? Now you guys can do the same thing. Uncommenting these lines essentially says, all right, enable the admin application. Admin.autodiscover is going to go into each of my apps. It's going to look for a file called admin.py, and it's going to load the administrative, it's going to basically load the tables that I defined in there for administration out of there, and it's going to build the administrative interface for me. You'll notice that anything under /admin is going to go to admin.site.urls. And Django provides a couple of things by default for me in the admin interface. So I should be able to go to /admin now. And, oh, I need to change my installed apps as well to include admin. My bad. In my settings.py, I have to uncomment the admin application. Right? So we actually have three things to do. We have to uncomment the admin application in settings.py. And then we just have to uncomment those lines that are already in my project level URLs.py to include the admin interface. And all of a sudden, you'll notice I get this really nice page. I'm going to log in here. And you'll notice that what Django does is it gives me this really nice administrative interface. Now you'll notice the auth and the site stuff. Well, the auth and the site stuff were provided by the auth app and the sites app. Those were already included. I've already synced them up to my database. That's why I end up seeing them here. But what I don't see is I don't see Hello World, right? So what I'm going to want to do is I'm going to want to add the models for my Hello World app into the admin interface. Now, adding models into the admin interface is really simple, but making them easy to manage in a very, very easy way, okay, for lack of a better word, is a little bit more complex. Simply adding them and making them there and making it so that you can modify those fields and create new records is easy. But if you want to be able to, for example, show relationships in like a vertical form for a particular record and stuff like that, like if I want to click on an event and see a list inside of that event of all the people that are registered in the event, you know, those require a little bit more work. The admin interface provides the tools and techniques to do all of that. If you look at the Django docs, you'll see all that stuff. And it's really a matter of, you know, how complex you want things to get. For the purposes of what we're doing, we're just going to add some of these models into the admin interface so we can look at them. So let's go ahead and do that. The first thing I said I needed to do is I need to go back into my app, and I need to create a new module called admin.py. Now, inside of that new module, I'm going to do a couple of things. First of all, I'm going to go ahead and I'm going to import my models, and I'm going to say from django.contrib import admin. So I'm going to go over here to admin.py. I'm going to say from django.contrib import admin, from hello world import models, right? Now in this case, what I'm going to have to do is for every single one of the models that I want, I'm going to create an event admin object. And that event admin object is going to inherit from admin.modeladmin. So I'm going to go ahead and say class, not event object, well, in my case, event admin. And now over here, what I'm going to do is I'm going to just show things like, okay, when I display this information, I want to see columnar views, right? And that's actually what's happening right here. List display equals says I want to go ahead and display a vertical list that shows me the fields. Whoops. There we go. So I'm going to say list underscore display equals, and in this case, for my event model, I'll go back over here to models. I have start date, name, and end date. Well, I'll go ahead and put all those in. And I'm going to do that same thing for my other model. And in this case, I call that model people, first, last, and event. Great. First and last. All right. Now, once I've actually defined what those fields are going to be, what I need to do is I then need to register these things, right? And that's actually what admin.site.register does, right? Admin.site.register, that auto-discover thing, goes and loads every single one of the admin.pys. And then the admin site registers here are going to go ahead and it's going to register a model with a model admin, right? So here, what I'm going to do is I'm going to say admin.site.register. The model in this case is called event, models.event, and event admin is going to manage it. And that's it. What I've now done is I've built the administrative interface for my app. Once again, you'll notice that this is all tied to the app. It's inside of the app's directories, and it's included with all the other app stuff. That means that if somebody is including this app in their project and they enable the administrative interface, bam, they're automatically going to get the administrative pages or the administrative stuff for this particular app. Let's reload this site administration page and see what it looks like now. Okay, one of the problems with the development server is that that admin stuff uses auto discovery, and the auto discovery doesn't get rerun when I make a change to the code. So what ends up happening here is it didn't reload it for me. So I had to go back and I had to reload the development server. But you'll notice as soon as I reloaded the development server, very nice. There's Hello World, right? There's my Hello World app. There's event and there's people, events and peoples, right? Remember how I said before that sometimes the pluralization is a little bit weird, right? Same thing. People was already plural, right? I probably should have called that model person instead of people, but such is life. Then it would have been persons right over here. And you'll notice that now I can click on one of these models. And when I click on the model, hey, look at that. There's my vertical display. And if I click on a record, you'll notice that now what I can end up doing is I can delete the record, and I have very nice, jQuery type-ish things where I can click on buttons and choose from a calendar and so on and so forth. Questions about this? I can go back to events. If I want to, I can check some events and I can delete those events, right? And if I want to add a new event, that's easy too. I go to this add event page. And if I go to peoples, you'll notice that once again, there's the first and last name, right? And now I can see all this information related to me as well. Questions about this? Now I can modify that. Now you'll notice there's a couple of things here that are kind of weird. When it says event here, it says event object. The reason is what Django does is it finds the events that are related to this person record, and then it returns this string representation and uses that to populate this particular dropdown. A way to fix that would be for me to go over to my model and define a string representation, right? So I could say something like, right? I could do something like that, right? And now what I can see is if I go back over here, now the string representation is actually the name of the event. So now I can see the events in here, right? So the idea here is that the admin interface, I mean, what did this take? It took me like 2 minutes, right, to build this administrative interface for this thing. If I had 60 models, maybe it would take me a couple minutes longer. But the idea is a simple administrative interface, and adding and removing records and so on and so forth is as simple as doing this, right? Now the thing is the other cool thing that the administrative interface allows me to do is it allows me to manage user accounts. So I can create more user accounts. All of this stuff here, these filters, those are all things that we can define. Over there where we define the administrative object, right? So model admin, that's where we can define things like how we want these filters to appear, how we want things to appear inside of these fields and stuff like that, right? So this is kind of like taking it to the next step. Okay, don't write down my password. It's obviously what I use everywhere. The idea here is that, all of the information here, right, I can manage, right, last login and so on and so forth. And I can create groups, and I can provide access to things via groups as well. All that via this administrative interface. Questions about Django's admin? Yeah. Sure. Well, there's a couple of things. Django does provide this concept of fixtures to load data, right? So there's mechanisms where we can do that. There's also anything that you can parse with Python, right? You can essentially iterate over, and you can use the model, right, to basically import the data, right? So you could iterate over a CSV of users and their unencrypted passwords, which we all know we keep around everywhere, right? But users and their unencrypted passwords, and as we iterate over it, we could use something like Python CSV dict method to convert it into a dictionary. That dictionary, if we have the column names correct, we can just do a people, models.people, and then ** KWRs. If it matches up with the dictionary field names, then it'll automatically create the object, right? So there's some pretty simple methods that we have to do that. Django fixtures is one. Another one is writing our own. And then, of course, you could always use some other database bulk load mechanism. The fact that you're using Django doesn't preclude you from doing other things with the database, right? So anytime you have a database bulk loader or some sort of ETL tool, you can accomplish the same sorts of things using those mechanisms. Other questions? No? Where are we time-wise? Okay, we're good. All right, so that's the admin interface. Access control. So Django has support for cookies. Every single time we have an HTTP request object, there's a dictionary defined called cookies. You can just guess. That cookies dictionary contains key value pairs. The key is the cookie name. The value is the value that's stored in the cookie. So every single time a request comes in, we have access to all the cookie information. In addition to that, Django has a method called setCookie. Actually, our HTTP response object has a method called setCookie that allows us to pass in a bunch of arguments, either named or positional, to end up creating a cookie on the client, right? Now, let's face it, these days a lot of people don't create cookies for example, applications that require things like login. Instead, what we'd rather do is we'd rather have session handling, right? We'd rather handle things via session. Well, Django does that as well. I'll talk about that in just a second. If you've written cookie handling code in any other language, right, or even using any other tool in Python, you're probably used to the parameters that are here. They're spelled out, but you can also look at the documentation for setCookie in Django. Django has a session framework. If you want a session framework, or if you want to use this session framework, what you've got to do is you've got to install an app called django.contrib.sessions and add a new middleware class called Django contrib sessions middleware session middleware. Now, middleware is essentially something that sits inside of the request cycle, right? So before information is passed into a particular view, the middleware, it passes through the middleware. And then what the middleware can end up doing is the middleware can look at the request. It can add information to the HTTP request object so that it's passed into those views. One of the things that the session middleware does is it changes the request so there's a .session variable. And that session variable essentially acts like a dictionary. Whatever you store in it is going to be stored in the session. And whatever you grab from it was loaded when the request comes in. So the request comes in, it passes through the middleware. The middleware creates that thing by loading the session data. And then when the request goes back out, or the response goes back out, what it's going to end up doing is that information that was inside of the session dictionary is going to get saved back, right, into the database or whatever your backend data store is for the session. Django has lots of different ways that we can store session information, ranging from the database to memcache to whatever other custom mechanism you want to make. But the idea is that what we end up getting with sessions, right, is we end up getting a request.session attribute, and that request.session attribute is like a persistent dictionary, right? Once something is set there, it persists until either the session timeout elapses, which I don't know what it is off the top of my head what the default timeout is, or until the user clears their cookies or closes their browser, right? So the idea is that, perfect example right here, right? We can remove stuff from the session, we can add stuff into the session, and we can manipulate the information that's in the session using code just like this, right? And this is like the simplest possible example I could think of is a counter, right? Every single time you visit the page, the counter increments, and it prints out one of the things that's there, right? Questions about this? No? All right. Django auth. You've seen some auth stuff earlier. The whole idea behind Django auth is that it provides us with a bunch of views and tables to manage authentication. So the views allow me to do things like reset passwords, login, and so on and so forth. And then what I've got is I've got a bunch of functions that I can use, right? Methods that I can use to the request object that allow me to find out information about the user, right? So HTTP request.user is an object, right? And it's actually a user object. So it's actually, if you delete it, for example, it would delete information from the database. It would delete the user that was currently logged in. But we have methods like isAuthenticated, isAnonymous, getFullName, and so on and so forth that allow me to basically find out information about the user, right? So once the user is logged in via Django's login view, we can go ahead and we can see who's logged in. We can see what that user's name is, and so on and so forth. example over here of login and logout pages. One of the things that Django's auth views provides is some generic login and logout functions, where essentially what we can do is we can provide it with our own templates. That way I don't need to use Django's very generic looking Django login template. And you saw that earlier when I logged into the administrative interface. Instead, I can use a template that's very, very specific to my site, right? So we can go ahead and it can use a specific template for login and logout. If you look at the generic ones, there's a generic registration login and registration logout. With both of these, the idea is that the template itself can contain information about the next page that the user should be forwarded to, or it's included as part of a GET request. So the idea is when the user's logged in, or once they've logged in, it forwards them over to another page. We've also got this concept of decorators, where what I can do is I can decorate a view to say login is required. And if you haven't logged in, what it'll do is it'll redirect you to the login page, and then once you log in, it'll redirect you back to that view. So Django's smart enough with the use of a simple decorator to say, hey, this is a protected view now. You have to be logged in. Similarly, there's decorators that say things like, you have to be logged in and you have to have this permission. So for example, you have to be logged in as a super user, or you have to be logged in as the news administration group, or you have to be logged in with some other sort of criteria, right? And we can even go so far as to provide it with some Lambda functions and say things like, you have to be logged in and the time has to be between, 10 p.m. and 10:05 p.m. before you can access this particular view. Right? So we have a lot of flexibility in terms of decorating and protecting our views. And the idea behind using a decorator is that none of the authentication components need to be inside of our view functions themselves. All we have to do is add them to the view, and bam, now that view is decorated and it's protected. Right? And that's actually what you see on page 83 here with the login required decorator. This is the simplest auth decorator I'm going to talk about here. Basically, it says you have to be logged in if you want to use this particular view, right? And all we need to do is from django.contrib.auth.decorators, import login required. We decorate our views, and now you have to be logged in to use it, right? When you're logged in, that means that we're going to be able to retrieve information about the user very, very simply. We saw it on the previous page, right? It's going to be request.user.whatever, right? And that's going to allow me to retrieve the user-specific information. So maybe I can show you the events that you are registered in versus all the events. Questions about this? All right, Django has lots of contributed apps. I think I kind of already talked about this. This is the example for the auth app, but if you go out to the Django docs, there's tons and tons of different Django apps that are out there. There's lots of them are on GitHub where people have written their own apps. Some of them are in Google Code. And then, of course, there's lots of Django contributed apps, right? But there's apps to do all kinds of stuff. There's apps to do, I've already talked about things like blogging and whatnot, authentication. My favorite app for Django is also a contributed app. It's called the GIS app. It's essentially what we call GeoDjango. GeoDjango has the ability to actually use geospatial queries, so we can do spatial queries like location-based services or location-based queries, polygon-based queries, things like that. Very, very nice if you're in the GIS space. All right, generic views. This is almost at the end here. So the idea behind generic views is a generic view is essentially a view that Django provides us with. Turns out that there's a lot of cases that you're going to encounter where what you need to do is you just need to render a simple template, right? Maybe you don't need to provide a lot of variables into that template, or maybe you have 3 or 4 static variables that you generally provide into the template. That's basically what generic views are. Direct to template is a generic view that basically says, here's a template, here's extra content I want to include, go ahead and render it, right? So this is for mostly static pages, pages that aren't going to end up changing a lot, but that you want to render through Django, right? Very, very simple mechanism of throwing things in. The other thing that sometimes what people will do is they'll go and they'll use things like direct to template to render like more generic views. So maybe as part of a URL, we're going to have some information that's generated, and we have a bunch of generic templates that are related to some sort of title value, right? So we dynamically choose the template we want to use, and we use direct to template to generate the output, right? And then, of course, if direct to template returns a template does not exist exception, then we're going to go ahead and raise an exception that says, hey, you know what? That template just isn't there. So you get a HTTP 404. Now, that's another thing I didn't really talk about earlier. Django does have a couple of cool exceptions. The most important one, my favorite one, is HTTP 404. 404 is a 404 error. Normally, when you raise a 404, you create an HTTP response and you say that, I want the response to be a 404 response. Well, by raising the exception, I can basically just go ahead and throw it, right? And Django is going to end up catching it and returning the appropriate page, right? So Django is going to do some basic exception handling there, grab a certain class of exception, HTTP 404, and handle it. I think there's an HTTP forbidden exception as well that you can throw. They're really just shortcuts to having to go through the code and actually return something, right? You bypass all the other stuff in the case that you're returning one of these exception types. Hey, that's my last slide. All right, a couple of things I want to talk about here. One of the things that Django provides us with the ability to do, it has the ability to create or generate and manage forms. What I want to do is I want to go ahead and I want to create a file inside of my app, and I'm going to call it forms.py, right? Forms.py is actually a Python, Django's forms module is what I'm going to use here. The whole idea behind Django's form module is that it allows me to generate forms using, once again, sort of a Python-specific syntax. So from Django.forms import model form. Now, normally what I would do is I would say from Django.forms import form, because I'm creating a form from scratch. A form from scratch doesn't have a model tied to it, so what it'll end up doing is it'll end up allowing me to define the fields that are in the form, and then it'll end up allowing me to define things like rules and requirements. I can define or I can attach to that model form a validation logic for that particular view, or for that particular form. These values have to be within this range, or these two values have to be the same. It'll also do some basic validation. So for example, if I say, here's a form with the date time field, it's going to do two things when I validate the form after I get the response. The first thing it's going to do is it's going to make sure that it is an actual date time field. If someone puts in a value like January 1st, 19, blah, 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 it'll auto-recognize a lot of those specific, user-specific notation, and it'll return to me cleaned data in the form of a date-time object, right? So if it's a date-time field, the form's going to give me back a date-time object. So I don't need to worry about parsing or managing. If it's an integer field, it's going to cast it over to an integer, and it's going to return to me an integer object. So I don't need to worry a lot about validation, right? The forms object can automatically generate the form for me, and it can also regenerate the form on the page. And when it does that, it can actually generate, with that regenerated form, the error messages and so on and so forth as well. So really cool. But in my case, I want to do something a little bit different. I'm going to say from hello world, import models, right? So here I'm going into my app and I'm importing the models. And what I'm going to do is I'm going to go ahead and say event form, class. There we go, right? In this case, what I've done, I'm doing all this from memory, so hopefully I'm not making any mistakes. But in this case, what I think I've done is I've said, look, I want Django to automatically build a form based on this model called models.event. Now what I want to do is I want to throw this form on a page. So what I'm going to do is I'm going to go back over to my views. If I can find my, here we go. And I'm going to go ahead and say from hello world import forms, right? That's what I call the module that contains forms. And now what I'm going to do is I'm going to say form, and I'm going to say forms.event form. And I'm going to create an instance of my event form object, right? So I just created an instance. There's nothing in it, per se. It's an empty event form object. And then I'm going to go into my template. Let's see here. Method equals get. What is it? Action equals. Nobody here knows forms, huh? Action equals? Yeah. And now what I'm going to do is I'm going to go ahead and put that form in there as a template. Now it turns out that the default rendering is for it as a table. And what I'm going to do is I'm going to say tr and hopefully that's it. Let's go ahead and try and reload our welcome page. Hello world. Oh. There we go. You'll notice that it's done something pretty cool here, right? What it's actually done is it's automatically generated a form, start date, name, and end date, right? So it's got the fields in there for that particular form, and it's allowing you to put information into it. Questions about that? All right. Well, let's take this to the next level, right? I'm going to do a couple of things. First of all, I don't want this to be a get form. I want it to be a post form, right? Because obviously I'm going to be changing data in the database. Logically, post is the better way. Rather than creating event form over here, I'm going to say if request dot, there's a way I can check to see if it's post, and off the top of my head, I just don't remember what it is, to see whether or not the data is being posted. But all I'm going to do here is I'm going to say form dot I'm going to show you guys a couple of things here. We're good on time here. So, all right, let's talk about what's going on here. So the first thing is that I'm checking to see whether or not the field is there with a key of name. It's going to be ID underscore name. It's actually, no, ID underscore, no, name equals name. Okay, great. All right. So what Django is going to do for me, right, is Django is going to render this form. Now, in my case, what I'm doing is using a little bit of a hackish technique here, but I'm checking to see inside of my view, whenever someone submits this view, whether or not there is a request.post variable called name. And if there is, I'm going to say, okay, somebody submitted this form. If there isn't, I'm going to generate an empty form, and I'm going to throw it on the page. That's what's happening here. Empty form thrown on the page, right? I'm going to make sure that my result initializes to none, because obviously if there is no result, I don't want to find that this variable is not defined. So what I'm going to do here is I'm going to go ahead and say, all right, if its name is there, I'm going to go ahead and I'm going to take post, I'm going to pass it into this event form object. Now what Django is then going to do is it's going to go through a validation step. It's going to take that data, it's going to return to me a model form object that represents what was in the form based on the information that came out of post, and it's going to put it in this thing right here. And when I call isValid, it's going to do a bunch of validation checks. It's going to make sure that the data meets the requirements for the database, blah, 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 et cetera, et cetera. When it's finished doing that, what I'm going to say is, oh, well, it's valid. I'm going to go ahead and I'm going to save it into the database. Now, when I take a form that's generated from a model and I save it into the database, what it ends up doing is it ends up giving me back a model object representing the information that's just been saved in the database. So I can take a form that someone submitted and turn it into model data. Now the commit equals false there basically says when you save it, don't commit it into the database. Don't create the primary key, don't put the data there. Because maybe I want to manage or manipulate the data a little bit more, a little bit later, right? But for now, all I'm going to end up doing is I'm going to create the model object. I'm going to print the name field just because. Now when this name field prints out, that's just there to show you that something has actually gone in. I've got a model object. What it's going to do is it's going to show up in my little Django debug thingy-majigger, right? So that debug window, that output that I'm seeing, whatever I print inside my Django code right now, generally you're not going to use print, you're going to use the logging mechanisms that are there. But for now, we're trying to keep this short and simple, so we're going to go ahead and just print it. It's going to show right up here, and we'll be able to see that the name is there based on what I entered. And then what I'm going to do is I'm going to create an empty form so I can throw it back on the page as an empty form, and I'm going to put in a result, and I'm going to say, look, this is what the PK was. Now obviously, this commit equals false. I don't want that there. It's good for you guys to see that I can do it, but I don't want it there because I really do want to commit it. Otherwise, I'm not going to have a primary key to show when I try and put that information back on the form. Great, so we've gone through and we've taken our model, we've converted it into a form, and now we've got a page that allows me to actually put data in there. Let's give it a shot and see if it works. My development server is running. I'm going to reload this page. I got to change that result from none, which displays in the template as the word none, to just a set of like an empty string. So I'm going to go ahead and change this to the empty string. And let's reload that page. All right, start date, 2011-01-01, 12:59:59. It actually should be start timestamp. A name, my first test event, 2011-01-02, 12:59:59. Now, one of the things I could go through, we didn't talk about here, but I can put a lot of validation logic in the model. One validation logic component I might want to put in is to say that your start date has to be before your end date, because obviously otherwise the event doesn't make a lot of sense. But let's go ahead and try this. Oh, okay. One of the things that Django provides us with is it provides us with cross-site request forgery protection. In order for me to actually create forms that work, CSRF token, I believe is what it is. I need to provide a cross-site request forgery token for every page that I generate. And if I take a look here, let me make sure the token actually made it in there. Yeah, you'll notice that what it ends up doing is it ends up putting this middleware token in with a value. You guys see that? That CSRF token is basically going to help me protect against cross-site request forgery. You can read about it in Wikipedia. Great. Send data. Hey, look at that. Saved data with PK of 2. And if we go back and we actually look at our interface, you'll notice that it printed out right here my second test event. What I've just done, right, is I've gone from having a model to generating a form and putting it on a page, and automatically taking care of saving the data that comes out of that form, validating the data. I guess validating happens before saving, but validating the data that comes out of that form, creating a model from it, and then saving that model into the database. Yes? So cross-site scripting, no, you don't, but the thing is, this cross-site scripting is not really related here. Everything that is put into a Django template, unless you mark it as otherwise, is always encoded, right? So it takes the greater than and less than symbols and so on and so forth. So you can't have a template variable that has cross-site scripting injectable variables in it without manually marking it as safe somewhere, either in your function, your view function, or inside of the template itself. There's a safe filter. So in that way, Django prevents cross-site scripting, right? So the templating framework does that for you, but that wouldn't really be related to this stuff where we're talking about, really model and model saving. Other questions? Okay, so there we go. We've saved something into the database. I'll do one more example really quick, and then we'll see where we are. Maybe we'll do some questions. I'm going to do the same thing, but instead of doing an event form, what I'm going to do is I'm going to go ahead and do a people form. Right? So models.people. I'm going to go back over here to my view, And I'm just going to take the really short and dirty way to do this. I'm going to just go ahead and say people form instead of event form in here. Right? And then I don't know if the field is name. I think it's first is one of the fields that I created. So there's, now we're doing it using my people form instead. Let's reload this page. And this is what I wanted to show you guys. You'll notice that the form is now built. There's a many-to-many relationship, right? Because there's a many-to-many relationship, you'll notice that what Django does is it provides me with a select box, a multi-select box, that allows me to select those related records. Now, the reason it shows me the event names here is I defined the string representation for those models. If you guys remember before when we were doing the admin interface stuff, I said, hey, if we define the string representation, then something really cool is going to happen, and then something really cool did happen, and you guys were all excited? Okay, so that's actually that cool thing happening again here. What's happening is that it knows what the relationship is, and it knows that we need to select related events, so it's going to go ahead and show that to me, right? Now I can do the same thing. I can type in a first and last name. It's going to create the person record, and it's even going to create the link between the events table, that many-to-many relationship for me. Now, one thing I'll point out from a model perspective, right, is in the model, the many-to-many relationship was defined at the people model, right? If I had defined the many-to-many relationship here, when I added an event, it would show me the list of people that I could choose from, right? So it really depends in this case on where I define that many-to-many relationship. Now, a couple of other things about model form. I don't need to use all the fields, right? In this case, I'm using all the fields because I'm inherently lazy. But I don't need to use all the fields. One of the things that I can do is I can exclude fields from the form. That way, maybe something like modified date, I don't want you to provide as the user. I want to provide that because I know. Or remote IP, because I want to log where this form was submitted from. Maybe I don't want you to provide your remote IP because I know that you're not going to tell me the truth. Instead, I want to rely on what Apache gave me, right? Which you spoofed anyway, but because you hacked into my router. But the point is that all this information, right, we can choose to mix and match things, right? And of course, with model form, I can add additional fields that aren't part of the model, right? So I could say, look, I want these fields that are part of the model, and then I want this other field or other two fields that aren't part of the model. Once again, if you look at that Django cheat sheet, right, that I kind of threw up for a couple of minutes, if you do a Google for Django 1.3 cheat sheet, you know, I highly recommend you go home, you print that out. A very, very useful piece of documentation. But you'll notice there's all kinds of model form fields that we can have, just like we had those form fields with respect to our models, or not form fields, but those fields with respect to our models. So there's kind of an analog there when it comes to form fields in Django. All right, we've got a little bit more than 10 minutes left. So there's a couple of things that need to happen. First of all, questions. If anyone has any questions, feel free to ask. And while I'm answering questions, I'm supposed to ask you to fill out a form. Not done using Django, unfortunately. But a form nonetheless. It's up here. Can you guys see that? Let's see if I can. I know that there's a way to do this. Oh, there we go. There you go. For those of you that are visually impaired or whatever, I mean, so you guys can see this. But that's pretty much all I got. So we got 10 minutes for questions, and then it's party time. Yeah. No, there's no whiteboard here. All right, I'll give you guys a minute to write that down. It's not by any chance on your. No, I know. I probably didn't print it anywhere. SurveyMonkey.com/s/PyCon2012 tutorials. You'd think they would have used Bitly for that or something, right? Everyone got it? Okay. If you don't have it, you can look at your neighbors. All right, now I got to figure out how to. There we go. Okay. So my view. All right. So there's my view again. Right. I've never been asked that question before. It is whatever they are in the model by default. So you could change the order in the model. So the thing is that one of the things that I'm doing right now when I render this form on the page, I'm kind of limited in time, but there's a number of different strategies or mechanisms I can use for rendering. The default is to render it as a table, but there's an as p that allows me to render it using like different tags and stuff. And you can control the rendering on your own. So you can say, all right, put this form field here, put the description for this form field here, put the errors for this form field here. One of the things I didn't show you, which I probably should have, I'm going to pop away from the view here for a second, but I'm going to try and put in a really long last name, and it won't let me put in a really long last name, but I'm going to leave the first name blank, and you'll notice that the form, when it regenerates on the page, there's an error message there, right? I can control where those error messages go as well, right? So if you look at Django form objects, inside of template rendering, there's a number of different ways that I can control the way the form object is rendered. So even though I may not be able to control the default order, I can definitely put the fields on the page in the order that I want, and the errors where I want them to go, and so on and so forth. Yeah? So the question was, how do you publish a Django application? There's a number of different deployment strategies that are out there. My method of choice is using mod WSGI in Apache. So the idea would be inside of your settings.py, there's a number of settings that are related to, test and development versus deployment, right? I would set, for example, debug to false because you don't want people visiting your page to actually see all your debug output and whatnot. But you would essentially set those settings, and then you would configure Django to be a WSGI application, right? Now, if you go out on the web, Django docs, there's some documentation about it. I think there is a tutorial that is Django deployment strategies. There was at last year's PyCon, or the year before's PyCon, or maybe it was last year's PyCon. But there's a number of different ways that you can do it. It's a matter of choosing your. I think it supports mod Python still. And then there's WSGI, which is the most common method, among other things. So, yes, again. Django Django. The answer is yes. Right. I think there can sometimes be issues with the underlying database depending on how the database encoding is set up. But generally speaking, just like Python, all the Unicode stuff works. There's some internationalization components that are in there and whatnot. Yes. Wait, hold on. I saw his arm first, so. Yeah, go ahead. I haven't used PyCharm. I can't really make a lot of recommendations with respect to IDE. I tend to code in a number of different languages, and so I tend to use Eclipse. And I use a lot of I use RSE a lot as opposed to PyDev specifically. But that's almost a religious discussion, right? So somebody over there is in the Emacs camp, which is kind of like the dark. Well, no. Anyway, there's a question back there. Oh, yeah. So the question is that when you have a number of context processors, if one context processor provides the same key that another context processor provides, one's going to clobber the other. And the answer is, I believe that's the case. You could, and I don't know how you would do collision detection. I haven't tried, and I haven't tried to do that. So it's difficult for me to answer that question without actually. Yeah, so Oh, right. Well, you control where the context processors are. Context processors are a project level thing. Generally speaking, they're not an application level thing in the sense of global context processors. And then at the app level, you're going to have your own context processors that are specific to the app. So a lot of it may just come down to naming strategy, but you're not going to have one app load a bunch of context processors and another app load a bunch of context processors at the same time generally, because generally you're going to have your app level context processors, right, that you define inside of your, like the example that I showed way back where inside your app you had your own, and it wouldn't be global in scope, it would be app specific. Do you see the difference? The concept of a global in scope context processor, which is everywhere, right, versus something that would be more or less specific to a particular app, which wouldn't collide with other apps. But in that case, you would have to look at what context processor you had globally enabled and give it some thought. Other questions? No other questions? I have used them some, but not very much. So, yeah. So you can do that, right? What you can do is you can always have a form tag and a closing form tag, and have form 1, which is tied to model 1, form 2, which is tied to model 2, form 3, which is tied to model 3. There's a couple of things there that go along with that. First of all, if you think that there might be collisions, one of the things you can do when you generate a form on a page, when you create the form object, you can provide a prefix for that form object. So all the fields will be prefixed by something. In your case, maybe the name of the model that you're working with. And then in that case, when someone submitted the data, you would take post and pass it into form 1, peg toast, pass it into form 2 with the same prefix, take post and pass it into form 3 with the same prefix, and create 3 models from them, right? So you can definitely throw together n models. The other thing is you might want to have 30 instances of one form on a page, right? Which you could also do using the same prefix type strategy. Other questions? Yes? No. Well, yes and no. So the thing is that keep in mind that in Django, you're never writing any SQL, right? The ORM takes care of escaping all arguments that are passed in. Just like if you were to write SQL, you would escape all components that were passed in, right? And so Django, for that reason, is more or less, if you're using a model framework, SQL injection is a thing of the past, right? It's going to call the database-specific mechanism for quoting or parameterization of query or whatever to prevent you from falling prey to the SQL injector. So, the nice thing about Django is it is fairly, it's not like there's not a lot of stuff you have to roll on your own for security. If you're using templates, right, Django is going to assume that everything is insecure unless you tell it otherwise. When you're using the model components, Django is going to take care of all of the appropriate escaping and whatnot. When you're using forms, the default for Django is to put in, to require cross-site request forgery protection. So cross-site request forgery is not something that's an issue. So the thing is Django takes care of a lot of this stuff for you without a lot of forethought on your part, right? It's when you want to break the rules that it takes a little bit more work sometimes. Like if you want to allow SQL injection for whatever reason, right? Any other questions? If there's no other questions, and it's 12:18 now, I think we're supposed to end at 12:20, but maybe it was 12:10 and we're 8 minutes over. I don't know. But thank you very much for coming. It's been fun. I hope you guys learned a lot. My email address is on the internet somewhere. No, it's on the tutorials page. I think there's like the instructions that were there for this tutorial. My email address is there. If you have questions, feel free to email me. Have a great time at PyCon, and thanks a lot for coming. And I hope you did the survey. And I hope you said nice things. But if you didn't, that's okay too. Thanks.